What natural or exotic phenomena could explain the irregular dimming of Tabby's star? And why does the possibility of an alien megastructure, though unlikely, capture our imagination? The sky above is vast and silent. As you settle into rest, imagine yourself floating up into that darkness, leaving behind the noise and weight of the day. Stars glitter all around like a million gentle eyes in the night. The Milky Way forms a pale river of light overhead, and beyond it lies the endless expanse of the cosmos. Perhaps, as you leave the world behind, you drift past a tiny, silent traveller launched decades ago, the Voyager spacecraft. It glides onward with a golden record strapped to its side, carrying whale songs and human greetings, a message in a bottle cast into the cosmic ocean. You and Voyager are fellow wanderers now, both on journeys into the great beyond. You glide beyond the orbits of the outer planets, past the realm of icy comets. The planets that were once familiar are now just faint points of light, nearly lost in the sun's distant glow. If you pause and look back, you might still catch sight of Jupiter as a tiny speck, or Saturn's rings catching a last ray of sunlight, or the pale blue dot of Earth barely discernible in the twilight of the solar system. But gently you turn your gaze outward again. In this serene darkness, your body feels weightless, your mind unburdened. There is no up or down out here, only the gentle pull of distant gravity wells shaping your path. The sun itself has become just another star behind you. Even the closest neighbouring star is unimaginably far. With our fastest spacecraft, it would take tens of thousands of years to reach it. But in our voyage of the mind, we are not bound by such limits. We drift faster than light, propelled by curiosity, crossing the light years as if they were gentle steps. Star by star, we move outward. Ahead lies the deep unknown, and we venture onward into interstellar space, leaving the comfort of the sun's domain for the welcoming embrace of the stars beyond. In this tranquil void, every so often a mystery unfolds, a phenomenon that science has yet to fully explain. Find comfort in that unknowing, for it means there is more to discover. Each mystery is like a cosmic lullaby, a whisper of something unknown yet oddly soothing in its wonder. We begin our voyage in stillness. All is calm, until perhaps a sudden, inexplicable event breaks the silence, a signal that rings out like a solitary bell in the cosmic night. Far above, beyond the stars you can see, something flickers. It lasts only a millisecond, a brief tick in cosmic time, but it carries the energy of our sun shining for many days. This is a fast radio burst, a mysterious whisper from the deep reaches of the universe. Though invisible to human eyes, it arrives as a sudden pulse of radio waves, a transient beat in the silence of space. One moment, it is not there. The next, the universe rings with its quiet song, and then it is gone, leaving only questions in its wake. Astronomers only discovered these cosmic flashes recently, and they remain perplexed by their nature. Imagine an energy release so immense and so swift. In the blink of an eye, as much energy as our sun emits in weeks is unleashed across the cosmos. What could cause such a powerful, fleeting beacon? Perhaps a magnetar, an exotic neutron star with an unimaginably strong magnetic field, cracks open in a sudden starquake, sending out a burst of radio energy across space. Or maybe two dense stellar corpses merge and collapse into a black hole, their final moments announcing themselves with that single radio pulse. As we gather more of these bursts, patterns emerge. Some repeat from the same spot in the sky, again and again, while others speak just once, and then fall silent forever. It's as if the cosmos is sending out Morse code, and we have only begun to decipher the letters, not knowing what message they might spell. On Earth, these bursts arrive with subtle clues. Imagine a shout echoing through a misty valley. The high notes reach you just a heartbeat before the low notes. In much the same way, the higher-pitched radio waves of the burst arrive slightly earlier than the lower-pitched ones, stretched out by their journey through a fog of ionized gas. From that tiny delay between the burst's high and low tones, astronomers can deduce how much thin plasma the signal traversed. Each fast radio burst, in its brief hello, carries a record of the space it traveled through, encoding the density of the cosmic haze between galaxies. Even before fast radio bursts, the sky had given us other cryptic signals. In 1967, a young astronomer noticed a peculiar rhythm in a radio antenna's data. A steady beep from space, as regular as a clock. For a moment, she wondered if it might be a beacon from another civilization. They nicknamed the source LGM-1 for Little Green Men, half in jest. It turned out to be the first pulsar ever discovered, a rapidly spinning neutron star flashing its lighthouse beam each rotation. Not aliens at all, but an astounding natural phenomenon. A star the size of a city, spinning faster than a blender, sending radio blinks toward us. Even these pulsars can surprise us. Occasionally, a pulsar's steady beat will suddenly quicken or slow by a tiny amount. Astronomers call it a glitch, a starquake within the neutron star that makes it spin just a bit faster, as if the star's crust cracked and settled. No one is entirely sure of the details. The universe loves to keep some of its secrets. In the quiet, after one of those fast radio bursts, our journey continues, guided by curiosity and a sense of calm wonder. We drift onward through the starry expanse, open to whatever whisper or marvel might greet us next. Fast radio bursts are not the first mysterious flashes we've found. Decades before their discovery, the sky revealed another kind of brief fury, gamma-ray bursts. In the late 1960s, satellites designed to monitor nuclear tests stumbled upon intense bursts of gamma rays coming from space, unmistakably from beyond Earth. These bursts were fleeting, lasting only seconds or minutes, but incredibly powerful, momentarily outshining entire galaxies in high-energy light. For years they remained enigmatic. Astronomers had no idea how far away they were, or what could possibly produce such energy in an instant. Over time, better satellites caught these bursts and led us to their afterglows, fading embers in X-ray and visible light that lingered for days. By studying those afterglows, we learned the bursts were coming from distant galaxies, billions of light years away. What could be so potent as to be seen across the universe? We now think there are two major types. Some gamma-ray bursts mark the death of a massive star collapsing into a black hole, the star's final scream as jets of energy blast out of the collapsing core. Others come from the collision of neutron stars or a neutron star merging with a black hole, titanic crashes that warp space and time and send a flash of gamma radiation across the cosmos. Yet even though we have these explanations, gamma-ray bursts still inspire awe. One burst observed not long ago was so bright that if it had been in a nearby galaxy, it could have affected life on Earth. Thankfully, these cosmic explosions are usually far away, mere fireworks in the sky of our detectors. If you were drifting somewhere in intergalactic space and a gamma-ray burst went off in a distant galaxy, you wouldn't see it with your eyes. The light is too energetic and far. But with the right instruments, you'd detect a sudden spike, a momentary blaze in the darkness. It would be like seeing a flash of distant lightning on a warm summer night. Brief, silent, but undeniably powerful. In that moment, you'd witness one of nature's most violent acts. Yet from your safe vantage, it would just be a flicker of light. After the flash, all returns to calm. The memory of that burst, like distant lightning, might linger for a while in your thoughts as we continue our gentle exploration. The universe has been issuing these dramatic bursts for eons, and only recently have we caught on to their existence. Now, as we float onward, we remain watchful for any sign, any message, whether it's the soft whisper of a fast radio burst or the brief blaze of a gamma-ray burst. The night is full of momentary messages, and we are fortunate to tune in for a time. Not all cosmic mysteries announce themselves in a single burst. Some unfold slowly, over months and years, perplexing us in different ways. High above, in the constellation Cygnus, a distant star lived out its life quietly for a long time. Or so it seemed. Then, not so long ago, astronomers noticed something unusual about it. This star, informally called Tabby's star, began to dim and brighten in ways that defied all expectations. Stars might twinkle from our perspective on Earth because of our atmosphere, but that's just an illusion. This was different. The star's own light was genuinely fading. A telescope in space, watching thousands of stars for years, recorded that Tabby's star would, now and then, lose a significant fraction of its brightness for days or weeks before returning to normal. It was as if something huge was partially blocking the star, irregularly and without a clear period. At first the star shone steadily, as any normal star should. Then, without warning, it lost perhaps 20% of its brightness, a tremendous dip. Imagine looking at a lamp and seeing its light suddenly dim by 1/5, then come back days later. That's what happened with Tabby's star. Over a few years, it dipped multiple times, each dimming with a different shape and duration. Unlike the predictable wink of a planet passing in front of a star, which causes tiny, regular dips, these drop-offs were irregular and far too large. Something enormous must have occasionally been blocking a big chunk of the star's light. But what? Astronomers scratched their heads. Could it be a swarm of comets that happened to break apart, their dust occasionally veiling the star? Or perhaps a cloud of interstellar dust drifting between us and the star? The star didn't seem to have a close companion that we could see, ruling out a simple orbiting companion as the cause. Each idea struggled to fully explain the weird light pattern, and the mystery deepened. Data hinted that the star's light was dimmer at some colours than others during the dips, which pointed to dust as a likely culprit. Tiny dust grains can block more blue light than red. Indeed, the star also showed a very gradual fading over years, as if dusty material might be slowly drifting around it on top of the big dips. Yet no telescope could directly see any dust cloud or ring. If it was there, it was thin and elusive. In the absence of a clear natural explanation, some imaginations wandered to extraordinary ideas. One proposal captured the public's fascination. What if an advanced civilization had built something around the star? Colossal structures harvesting its energy, occasionally eclipsing its light. A so-called Dyson swarm, an orbiting megastructure, the kind of feat only a Kardashev Type II civilization might achieve. Could in principle dim a star unpredictably if it were incomplete or uneven. It was a far-fetched notion, scientists emphasized, a fun speculation once more mundane theories were exhausted. Most astronomers thought dust or fragmented comets were more likely. But for a while, the alien megastructure star idea made headlines, precisely because it was such a tantalizing scenario, perhaps evidence of intelligence on a grand cosmic scale. As more observations came in, the alien hypothesis seemed less necessary. The pattern of dimming and the way different colors of light were affected fit better with natural dust. The star gradually reddened when it faded, just as dust would cause. But still, the exact origin of that dust or material remains unknown. We may be witnessing the aftermath of a planetary collision, or the remnants of a disintegrating cometary family, or some other process we have yet to understand. Whatever the cause, be it dust or something more exotic, Tabby's star has given us a sense of wonder. It makes us ask, what other surprises lie hidden in the steady gleam of distant suns, waiting for patient observers to notice? Back on Earth, the star's story is still unfolding. Astronomers continue to monitor it, awaiting the next dimming, hoping to catch clues in the act. Tabby's star was the first of its kind, but since then a few other stars have been found with strange dips too, each case stirring excitement about aliens until careful analysis pointed again to dust or other natural veils. For now, Tabby's secret remains her own. 1,500 light-years away, flickering in the darkness. Picture the scene from a hypothetical planet orbiting that star. Most of the time, its sun shines steadily, illuminating the world just as our sun does Earth. But now and then, a great shadow sweeps across the sky, casting the land into an eerie twilight. Perhaps the sky darkens with a haze of fine debris during those times, or a colossal object passes overhead, backlit by the star's dimming glow. Then, as the shadow lifts, the star returns to its normal brilliance, as if nothing happened. The inhabitants, if any exist, might have myths or anxieties to explain those strange eclipses, much as ancient peoples on Earth once did for our solar eclipses. They might gather in astonishment or fear when their sky goes dark inexplicably, and rejoice when the light returns. As we leave that enigmatic star behind, the thought of alien megastructures lingers like a tantalizing dream. The universe is old. Over 13 billion years have passed since galaxies first shone. If intelligent life emerged on a faraway world eons before us, perhaps they have risen and fallen long ago. One can imagine drifting into a remote star system and finding the remnants of a great project. Enormous, silent rings or panels circling a star, long since abandoned. The star might be dimmer than it should be, wrapped in a dusty swarm of derelict machines. An entire civilization's work could remain as a ghostly shell around the star, a mausoleum in orbit, quietly circling for millennia. Picture a half-built Dyson sphere, deserted. Its skeletal framework glints faintly with reflected starlight as we glide past. You might see meteoroids that have punched holes through what once were immense solar panels, or comets now coating the megastructures in frost. There's no sign of its builders. They might be long extinct or moved on to higher realms, but their engineering marvel lies dormant, a monument to ambition. If we listen in, metaphorically, we might even catch a faint electromagnetic hum from an ancient computer still running on backup power, dutifully waiting for instructions that will never come. Such speculative scenes remind us that the cosmos could hold not just natural wonders, but also artifacts. if any advanced life managed feats on astronomical scales. So far, despite decades of searching, we haven't spotted anything that conclusively points to alien technology. But the absence of evidence isn't evidence of absence. The universe is vast beyond comprehension, and our search has only skimmed a few cosmic droplets from an ocean of worlds. The next strange light curve or uncanny signal might be the one that shows we're not alone. Or, equally exciting, it might unveil a new astrophysical phenomenon we never imagined. Either outcome would deepen the mystery and beauty of the cosmos. Contemplating these possibilities, we carry on with a sense of companionship. Not that we know of alien friends out here, but the mysteries themselves are company enough. They spark our imagination and keep us looking upward and outward. In the quiet void, even hypothetical echoes of distant civilizations become part of our gentle reverie, as natural a part of our voyage as the real stars and galaxies passing by. Our path now takes us beyond individual stars, into the realm of the planets that wander the galactic night. We have found thousands of planets orbiting distant suns, hot Jupiters skimming star surfaces, Earth-like worlds basking in warmth, frozen giants on the fringes. But there are also planets that roam alone, without any sun to call their own. These are the rogue planets, drifters in interstellar space, cut loose from any parent star. Far from the light of a sun, a rogue planet is cloaked in perpetual night. Imagine a world the size of Jupiter, cast out of its birthplace during the turbulent dance of planet formation, flung into the void by a gravitational quarrel, or a lonely planet that formed in isolation from a collapsing gas cloud too small to ignite into a star. A failed star, wandering by itself through the galaxy. Without a sun, the concept of day and night as we know it loses meaning. There is only endless night, punctuated perhaps by the faint combined glow of distant stars and the ghostly light of far-off nebulae. Maybe, once in a rare while, a rogue planet passes relatively close to a star and basks in a brief, dusk-like glow before moving on. What would it be like to stand on such a world? If it were a large gas planet, you'd have no solid ground, just an endless atmosphere getting denser as you descend, eventually transitioning into strange liquids and a hidden core. But envision a rogue Earth-sized planet with a solid surface and perhaps a thick atmosphere, under a sky filled with stars. No sun ever rises or sets. Time might be marked by the slow rhythms of the planet's rotation. Maybe there's a faint glow on one side from the galactic plane's starshine, and a deeper dark on the other side turned away. If the planet has internal heat from its formation or radioactive elements in its rocks, that warmth could seep out. Maybe it keeps a subsurface ocean alive beneath an icy crust, heated from below. Life could survive in such an ocean, clustered around hydrothermal vents, never seeing light, never knowing that elsewhere stars shine. On the surface, the landscape might be frozen and still. The air, if any, could be thin and biting cold, or perhaps thick with greenhouse gases trapping what little heat emanates from the planet's core. The sky would be black, of course, dotted brilliantly with stars, more stars than most of us ever see, since there's no sunlight to outshine them. You might witness ghostly auroras shimmering now and then if the planet has a magnetic field and it encounters the odd cosmic ray or particle stream. Those would be rare moments of dynamism. Mostly, all is tranquil and dark. If life found a way on the surface, perhaps it would carry its own light. One could imagine forests or colonies of organisms that glow in the dark, like a world full of bioluminescent lanterns, bringing a gentle radiance to the perpetual night. In the absence of a sun, life might become its own star, however faint and local. Some scientists speculate that if a rogue planet had a thick hydrogen-rich atmosphere, it could retain enough heat for liquid water on its surface, despite the cold of space, a sort of warm greenhouse bubble adrift in the void. And if it had water, perhaps simple life could emerge in a warm pond beneath a perpetually starry sky. It's a speculative notion, but it shows how interconnected the cosmos could be over vast time spans. Could life hop from star to star on these dark vessels? We don't know, but it stirs the imagination. Some of these free-floating worlds might even serve as arcs of life, carrying the ingredients of living systems across the galaxy. If a planet with life is ejected from its solar system, hardy microbes might survive beneath its surface, or in protected pockets, enduring eons as the planet travels between the stars. If by chance that rogue planet passes near another star system eons later, perhaps it could thaw out, or even have pieces of itself captured, seeding a new biosphere with its ancient life. Rogue planets might thus play a role in spreading life, a twist on the idea of panspermia, life's spores cast adrift, awaiting landfall on fertile shores. Drifting alongside such a lonely planet, one can feel the poignancy of its solitude. Yet there is a peace in it too, a steady state unbothered by the roar of a sun. The planet sails on, turning slowly under the starlight. Perhaps it carries a moon with it, the two companions keeping each other company on their long voyage. A moon could tug on the planet and keep its interior warm through tidal forces, creating a bit more shelter for life or geologic activity. In the sky of that planet, the moon might loom large, a faintly illuminated shape if it reflects starlight, providing one familiar sight in an otherwise alien sky. As we accompany this solitary world for a while, we appreciate the vastness between the stars. The distances are so great that collisions or close encounters are exceedingly rare. This planet will likely travel millions of years without coming near another star. It is free, following the subtle gravitational currents of the Milky Way's mass distribution. It orbits the galaxy directly, a dark ship sailing an endless ocean of night. Occasionally, it might silently pass through the outskirts of a star cluster, or graze a nebula, picking up a shimmer of distant light as it does, or perhaps capturing a stray moon that it encounters. Then it moves on, indifferent and slow, continuing its journey through the ages. We drift onward, leaving the rogue planet to its quiet odyssey. We carry with us the poignancy of its story, but also the serenity of its constant night. It's time to turn our attention back to the stars themselves, for even they can vanish in surprising ways. Stars are the beacons of the cosmos, shining for millions or billions of years. Most end their lives in well-understood finales, a dramatic supernova for the very massive ones, or a gentle puffing off of outer layers for stars like our Sun, leaving behind a white dwarf that cools like a fading ember. But on rare occasions, a star's light can simply cease with little warning or spectacle, as if a lighthouse were extinguished overnight, with no firework to mark the moment. Astronomers have actually searched for such vanishing stars by comparing old sky photographs to new ones. In at least a few cases, they discovered that a star once recorded in the sky is no longer visible years later. One striking example was a massive star in a distant galaxy that just disappeared. It didn't explode in a bright supernova visible across millions of light years. It simply went dark and was gone when telescopes looked for it. The leading explanation is intriguing. The star might have directly collapsed into a black hole. Normally, when a very massive star reaches the end of its fuel, its core implodes, and a shockwave blows the outer layers into space as a supernova, a celestial fireworks show. But perhaps sometimes, if the shockwave is too weak or the star too massive, the star could collapse inward completely, with most of it falling past the event horizon of a newly formed black hole. The star would then just quietly implode, swallowing itself from the inside out. To an outside observer, the star's light would simply fade and then wink out, with maybe only a brief flash of high-energy radiation or a burst of ghostly neutrinos as a telltale whisper. Imagine watching such a star from a distance. For eons it shines as a brilliant supergiant, outshining many of its neighbours. Then over a short span, perhaps weeks or months, it starts to flicker oddly and dim inconsistently. Perhaps this is its final struggle as the core falters. Then, one night, the star does not rise at its expected brightness. It's as if it has been replaced by a faint shadow of itself. Soon, even that shadow fades. In the sky, that star was part of a familiar pattern. Now there's a gap, a dark spot where it once glowed. If you were on a planet orbiting that star, the change would be catastrophic. One moment you enjoy the warmth and daylight of your sun. The next you are plunged into near total darkness, lit only by faint starlight from the rest of the galaxy. The temperature would plummet. It would feel as though the very sun had been stolen from the sky. There is a poignant serenity in this silent finale. A star that shone for millions of years simply slips away without fanfare. It reminds us that not every cosmic drama is a loud explosion. Some transformations are gentle fade-outs, quiet events known only to the universe itself until we happen to discover them. Such an unheralded death humbles us, emphasizing that even great stars can perish in soft whispers. We find something hauntingly beautiful in this idea of a star dying in silence, a colossal sun collapsing into endless night, without the universe at large even noticing immediately, a life concluded in privacy. It raises questions. How often does this happen? Are there many black holes out there that formed without a flash, hiding where a star once was? One clue comes from those ghostly particles, neutrinos. Interestingly, even a collapsing star would likely release a flood of neutrinos, nearly massless particles that rarely interact with matter. In a direct collapse scenario, as the core becomes a black hole, a burst of neutrinos could stream out, carrying away energy. These neutrinos would fly straight through the star's remaining layers, and through nearly anything else. Only a very sensitive detector would notice them. In fact, in 1987, detectors on Earth did catch neutrinos from a supernova in a nearby galaxy, arriving hours before the light. For a failed supernova, a similar neutrino flash might be the only herald, a final whisper from the dying star that only the universe's most elusive messengers can carry. If we ever build neutrino observatories much more powerful than today's, We might catalogue invisible star deaths by their neutrino signatures alone. From afar, though, a disappearing star is a quiet event. No spectacular burst announces its demise to ordinary telescopes, just an absence where once there was light. How quietly the mighty can fall. It teaches us that not all transformations in the cosmos are announced with grandeur. Some are subtle, like a leaf falling in a forest with no one around to hear it. A star's life ebbs into darkness, and a new object, a black hole, takes its place, hidden from direct view. And so, as we drift onward, we carry the lesson that absence itself can be an event. In that patch of sky, we sense the invisible presence of a black hole where the star once shone. Our journey naturally next leads us into the domain of those very entities, black holes, and the strange realms of gravity and time that surround them. The star's disappearance has guided us to the edge of a gravitational abyss. Black holes are regions where gravity is so intense that not even light can escape. They are in some ways the ultimate mystery of gravity. Matter wrapped so tightly around itself that it punches a hole in the fabric of space-time. A black hole forms when mass is packed into a volume so small that space-time curves in on itself, creating a true trap. The boundary of no return is called the event horizon. Once something passes that invisible line, it vanishes from our observable universe, drawn inexorably toward the center. If we drift near a black hole, not too close, we'd notice strange effects even before reaching the horizon. Starlight from the rest of the universe would appear distorted, perhaps smeared into a ring or halo around the black hole by its powerful gravitational bending. Time itself behaves oddly. Clocks far from the black hole would seem to run fast from our perspective near it. Conversely, to a distant observer watching us orbit a black hole, our time would appear to slow down. This is gravitational time dilation. Strong gravity stretches and warps time. If you hovered just outside a big black hole's horizon safely, you could watch the universe's future play out at a faster pace, while only a short time passed for you. And to an outside observer, anything you do near that horizon would look more and more sluggish as your light loses energy climbing out of the deep gravitational well. Imagine a traveller venturing closer and closer to the event horizon. As they descend, the light they send up becomes more redshifted, drained of energy, and their actions appear slower and slower to someone watching from afar. At some point, the traveller reaches the horizon, but to us outside, they never quite seem to cross it. Their image fades, redder and dimmer, asymptotically freezing at the threshold. From the traveller's own perspective, though, nothing particularly dramatic happens at that boundary, assuming the black hole is huge so tidal forces are gentle. They could float right past the event horizon and see nothing special at that exact line. No signpost saying point of no return, just the continued pull into darkness. Once inside, however, all paths lead inevitably toward the center. The center of a black hole, the singularity, in classical theory, is a point, or ring, for a rotating black hole, of almost infinite density, where known physics breaks down. It's like going over the edge of a cosmic waterfall. Once you've crossed that horizon, there's no climbing back out, and at the bottom lies something beyond our comprehension. In the mathematics, space and time, as we know them, effectively end at the singularity. What actually happens there is unknown. Does matter get crushed to an infinitely small point? Does it trigger some new physics, create a new patch of universe, or something even stranger? Our theories can't yet say. Some physicists have imagined alternatives to avoid this paradoxical infinity. One idea is the gravastar, a hypothetical object where a collapsing star is halted just before forming a true singularity. In a gravastar, the interior might become a strange bubble of ultra-compressed matter or exotic energy. There'd be no singularity, perhaps no true event horizon. It might emit a trickle of radiation. From the outside, a gravastar would look almost like a black hole, so we might not know if we've found one. It's speculative, a possible trick nature might use to sidestep the infinities of a classical black hole. Another wild concept is the naked singularity. Normally, every singularity we know of is hidden behind an event horizon, nature's way of censoring the infinity from our universe. But some solutions to Einstein's equations suggest that under extreme conditions, a singularity could exist without a surrounding horizon, potentially visible to the outside universe. Such an object would defy our usual notions of cause and effect. Near it, physics might behave in bewildering ways, with light and matter twisting in loops or emerging unpredictably. So far, we have no evidence that naked singularities exist. If they did, they might appear as points of infinite light or bizarre gravitational effects. Most believe that some undiscovered principle, a cosmic censor, always steps in to cloak them within horizons. Black holes themselves come in different sizes. There are stellar mass black holes, a few to maybe dozens of times the mass of our Sun, born from collapsing massive stars. Some quietly like the one we discussed, others in supernova. Then there are gargantuan ones lurking in galactic centers, supermassive black holes, millions or billions of times heavier than the Sun. Around those, like the one at the center of the Milky Way, space is severely warped, but the boundary can be so large that the gradient of gravity at the horizon is actually gentle. An object, or a person, in a fanciful scenario, could fall into such a giant black hole and pass the event horizon without being torn apart immediately, only to meet their end at the central singularity later. In contrast, falling into a small black hole, the tidal forces, the difference in gravity between your head and feet, would become lethal well before you reach the horizon, stretching you into spaghettified wisps. For our meditative journey, we'll keep a safe distance, admiring these curiosities without getting trapped by them. There's another layer to black hole mystery, the famous information paradox. According to quantum physics, information about a system, the specific details of particles and their states, should never be destroyed, even if the system changes form. But if something falls into a black hole, and the black hole eventually evaporates, we believe via Hawking radiation over mind-bogglingly long times, what happens to the information that fell in? Is it lost forever, or encoded somehow in the radiation that the black hole emits? Many theories abound. Some suggest the information is smeared on the event horizon and slowly imprinted in the Hawking radiation, the idea of black hole holograms. Others propose more exotic resolutions. It remains an area of intense research, a collision of quantum mechanics and gravity, where we don't yet have a clear answer. In a way, the black hole, quietly sitting out there in space, challenges our understanding of basic physics deep down. We have even managed to hear black holes, in a sense, not by sound, but by gravitational waves, ripples in space-time itself. In 2015, after decades of effort, the Laser Interferometer Gravitational Wave Observatory, LIGO, detected the faint tremor from two distant black holes merging. Over 1 billion years ago, two black holes spiraled into each other and collided, and the fabric of space quivered from that event. Those ripples expanded through the universe and eventually jostled mirrors on Earth by less than the width of an atom. Yet we measured it. It was as if the universe had played a deep, resonant chord on a cosmic instrument, and at long last we heard it. Since then, we've heard many more mergers, black holes, and even neutron stars. Each detection is like witnessing the final dance of massive objects in complete darkness. It confirmed predictions, but also raised new puzzles. For instance, how did some of these black hole pairs form? And are there even bigger surprises like black holes of unexpected size? Now we know the cosmos has a background murmur of these space-time vibrations. In the coming years, we hope to detect the slow rumbling waves from supermassive black holes merging in distant galactic cores, like a bass note echoing across millions of light years. From our safe distance, we continue to contemplate a lone black hole, perhaps the one left behind by that vanished star. We picture gentle starlight orbiting it, maybe an accretion disk glowing in X-rays if it's consuming some stray gas. Many black holes reveal themselves through such emissions. They're not entirely black when they have a snack, but a truly isolated black hole with nothing nearby to eat would be nearly impossible to find. A silent hole in space. It's intriguing to think of all the quiet black holes drifting in darkness. Relics of ancient stars, invisible except through their subtle gravitational lensing of background light or the effect on any stars that wander too close. Wormholes, hypothetical tunnels through space-time, beckon to us from the edge of speculative science and naturally follow black holes in our tour of mysteries. In the mathematics of general relativity, wormholes are possible solutions. Imagine bending a sheet of paper, representing space, and poking a hole that connects two non-adjacent points. A shortcut. A traveller entering one mouth of the wormhole could emerge from the other mouth almost instantly, no matter the distance between them in normal space, perhaps even in another time or universe. In our journey of the mind, we envision coming upon such a phenomenon in the cosmic ocean. What might a wormhole look like if it could exist on human scales? Perhaps from a distance, it could resemble a black hole, a spherical region where light is strongly bent and may be entering it. But unlike a black hole, which only pulls things in and doesn't let them out, except as Hawking radiation, a traversable wormhole might allow two-way travel. One could imagine it as a kind of crystal ball floating in space, where if you looked into it, you'd see not your reflection or the stars behind you, but rather a completely different star field, the view from the other mouth of the wormhole. Approaching it, the sphere might shimmer or show distortions at its edges, where the light from elsewhere meets the normal space around it. If one were to drift into such a tunnel, perhaps the transition would be surprisingly gentle. You might pass an invisible boundary and suddenly find the stars behind you have vanished, replaced by a curving tunnel of faint, streaky light guiding you forward. Ahead, a pinprick of light could grow, the exit looking like a distorted bubble showing a distant galaxy, or maybe another universe's sky. Time might flow strangely inside. What feels like a moment to you could correspond to years outside, or vice versa. It's all speculation, of course. Would the traveller survive such a journey? Our best physics suggests probably not. Without exotic negative energy matter to hold the wormhole open, it would pinch off into a black hole as soon as anything tried to go through. But let's imagine benevolently that this wormhole is stable and calm. In our quiet fantasy, it's a peaceful shortcut. You enter the darkness and soon emerge into a completely different sky full of unfamiliar constellations. The concept is as wondrous as it is daunting. So far, wormholes remain a beloved idea in science fiction and theoretical physics, but no evidence for them exists in reality. Some have speculated that maybe the supermassive black hole at our galaxy's center could be a wormhole in disguise. If, somehow, there were a through route and matter could travel both ways. If that were true, perhaps we'd occasionally see something bizarre, like stars, or gas disappearing into our galactic center and not reappearing, or sudden bursts as foreign matter pops out. We see none of that. Everything behaves exactly as expected for a normal black hole. So, if wormholes exist, they either are extremely tiny or hidden, or exist only in theory. Nonetheless, the very notion of them fuels our imagination and pushes our understanding of physics. Wormholes may remain purely hypothetical, but the idea of them is a testament to our longing to leap across the cosmos in an instant. They challenge us to think about what spacetime might permit. Even if nature never provides such convenient doorways, pondering them nudges us to explore the boundaries of possibility, and perhaps find other means to reach the stars. In a way, wormholes reflect our hopes of overcoming the vast distances that separate us from the things we love to wonder about. We drift around the envisioned mouth of a wormhole in our mind's eye, peering at the distorted stars within it, and then gently move on. The universe as we know it has plenty of wonders that do exist, awaiting our notice. We leave behind the idea of shortcuts and return to the long road, content to explore at our leisurely, contemplative pace. Our path now takes us into the realms that are both familiar and still mysterious, towards the center of our own galaxy, and then beyond into the wider cosmos. Our voyage now carries us out of our sun's neighborhood and into a broad view of the Milky Way. From this vantage above the galaxy's plane, we see the Milky Way as a luminous disk, a great whirlpool of stars with a bright bulge in the middle. Stars are packed more densely in the core than out here in the spiral arms where our sun resides. If you could stand on a world near that central hub, your night sky would hardly be night at all. It would be crowded with thousands of stars, far brighter than any we see. Cosmic city lights in every direction. In the Milky Way's heart, darkness itself is scarce. Even at midnight, the collective glow of innumerable suns might create a perpetual gentle twilight. We gradually draw closer to the galaxy's center, and hidden structures and phenomena reveal themselves. One remarkable feature, not visible to human eyes, but to gamma-ray instruments, are two enormous bubble-shaped forms extending above and below the galactic plane. These are the Fermi bubbles, discovered by a space telescope surveying the high-energy sky. Each bubble is tens of thousands of light-years tall, billowing out from the center like giant lobes. They glow in gamma rays, evidence that extremely energetic electrons, or other particles, inhabit them, colliding with lower energy light or gas. What made these bubbles? We think they might be the remnants of an energetic event in the Milky Way's core a few million years ago. Perhaps a burst of star formation and supernovae blowing a gargantuan galactic wind. Or a period when our central black hole devoured a large amount of matter and spewed out jets. Now the bubbles are like the ghost of that violence, hanging above and below the galaxy's disk. If human eyes could see gamma radiation, the sky around the constellation of Sagittarius, which points to the galactic center, would be dominated by two bulbous shapes stretching high and low, like celestial balloons. Deeper in the heart of the galaxy, another enigma appears in a specific hue of light. A glow at 511 keV, a gamma-ray energy, permeates the bulge of the Milky Way. This is the energy signature produced when an electron meets its antimatter counterpart, a positron. They annihilate and produce gamma photons of that precise energy. The presence of this glow means a huge number of positrons, anti-electrons, are being created and then annihilating, with electrons in the galactic center. But where are these positrons coming from? It's an ongoing puzzle. Possible sources include certain radioactive decays from elements made in supernovae, or pulsars, rapidly spinning, magnetized neutron stars that can spawn electron-positron pairs in their fierce electromagnetic fields. Yet the distribution and quantity of the positron signal are hard to explain with known sources alone. One exotic hypothesis: maybe dark matter particles are involved. If some kind of dark matter can annihilate or decay into electron-positron pairs, that could flood the area with positrons. Another startling idea. Perhaps there are a few anti-stars in our galaxy, stars made of antimatter, and when normal matter from space falls onto their surfaces, it annihilates and produces gamma rays. It sounds far-fetched, as the early universe was imbalanced toward matter. But astronomers have identified a handful of unusual gamma-ray sources that could, in theory, be anti-stars. If by some quirk of fate, small pockets of antimatter survived, they would be extremely fascinating, a star that if visited would destroy any normal matter probe sent to it in a burst of energy. So far, that's speculative, and these sources could just as easily be more mundane objects like pulsars or black holes. Still, the very thought that our galaxy might harbour a few ghost stars of antimatter among the hundreds of billions of normal stars adds to the sense of mystery. The galactic center has more in store. In radio wavelengths, we discover weird, thread-like filaments up to hundreds of light years long, hanging perpendicular to the plane near the core. They are highly magnetized and emit radio waves, indicating electrons spiraling along magnetic field lines. These filaments stand out as taut lines in the chaotic central region. What causes them? Possibly shock waves from past eruptions, like whatever created the Fermi bubbles, stretched and ordered the magnetic fields, or perhaps interactions of cosmic rays and molecular clouds shaped these tendrils. They look like strokes of a cosmic paintbrush, or strings on a galactic harp, revealed by the radio glow of particles dancing along them. Recently, dozens more have been found, forming intricate patterns around the center. It's as if enormous magnetic fibers are woven through the galactic core, normally invisible, revealed only because they accelerate particles to emit radio waves. Then there are the stars. Near the very center, a swarm of stars orbits our galaxy's central black hole, a beast of about 4 million solar masses at high speeds. They swoop around the dark mass like comets around the sun, some moving at thousands of kilometers per second. Watching their motions was how astronomers proved the black hole's presence. It's a crowded, dynamic environment. Stars can even collide or gravitationally scatter there. And every so often a star might venture too close to the black hole and be ripped apart, producing a flare of X-rays. We recall one such incident. A cloud of gas, called G2, plunged toward the black hole in 2014. Many expected it to be devoured messily, but G2 survived the encounter, passing the periphery and swinging away, merely stretched, but not destroyed. The black hole, for its part, usually dines only lightly. It's quiescent compared to the voracious active black holes in some galaxies that blaze as quasars. Even radio telescopes have caught odd behavior near the center. They've detected transient radio sources that flicker on and off over months, defying easy classification. Not quite like pulsars, not quite like anything known. Perhaps a new type of radio-emitting neutron star, or magnetar with unusual properties, or something else entirely new. The center of the Milky Way teems with such curiosities, reminding us that even in our backyard, on galactic scales, there are phenomena we don't fully understand. Rising high above the Milky Way's plane now, we take one last look at our galaxy. We see it as a whole, a broad, glowing spiral disk with arching arms and a bright central bulge, all embedded in a faint spherical halo. It is a breathtaking island of stars. After a moment of quiet admiration, we continue outward. With an affectionate farewell, we let the Milky Way's grand form shrink behind us. Our home galaxy becomes just another spark in the dark. We know hidden within it are those gamma-ray bubbles, whispers of antimatter and magnetic harp strings. But from here it looks calm and serene, a pinwheel frozen in time. Beyond our galaxy, we enter the domain of other galaxies and the space between them, an even larger canvas of mystery and wonder. Galaxies gather in groups and clusters. These in turn form larger structures. Our Milky Way is part of the local group, which in turn is on the outskirts of the Virgo cluster, all within the Laniakea supercluster, an enormous flow of galaxies we call home. The further out we go, the more grand the cosmic design becomes. Before we plunge into the truly ancient light of the cosmos, let's pause and take in the panoramic view of the large-scale structure of the universe. Galaxies are not strewn randomly through space. They are woven into a vast cosmic web. Imagine a network of filaments and nodes stretching across hundreds of millions of light years. Galaxies are strung along these filaments like pearls, and where filaments intersect, great clusters of galaxies form, the nodes. Between the filaments lie immense voids, cavities with few or no galaxies, like dark bays between the bright strands. This cosmic web emerged over eons as matter clumped under gravity's influence, tracing the pattern of the primordial quantum fluctuations from the universe's earliest moments. If you could somehow rise above the universe and look at this web, a godlike perspective far outside reality, but we can imagine, you'd see something like a luminous lace or sponge, a delicate tracery of glow against black, where each thread's light comes from the combined billions of stars in the galaxies that line it. Drifting now along one of the web's filaments, you would pass cluster after cluster of galaxies, cities of stars separated by vast expanses. Then you might enter a void, a region hundreds of millions of light years across, with only occasional lone galaxies floating in darkness. Crossing such a void would be like crossing a desert at night, starved of landmarks, nearly empty, perhaps the loneliest expanse in existence. Eventually, as you travelled onward, you'd approach another filament where galaxies congregate, and the sky would brighten again, with countless faint smudges of light, distant galaxies grouped in a great arching structure. We now broadly understand how this web came to be, gravity amplifying slight differences in matter density over time. But to witness it sprawling out before you is still breathtaking. Our own Milky Way is one glimmering node in this network, connected invisibly to far-off galaxies by the tendrils of gravity and the history of cosmic growth. It is humbling, and yet strangely reassuring. We are part of a vast, interconnected pattern. Amid this cosmic web, astronomers once thought, on the largest scales, the universe should be more or less the same everywhere. No special directions or preferred spots. But as we map these structures and motions, a few anomalies have surfaced that make us wonder. In 2008, scientists measuring the motions of distant galaxy clusters noticed something odd. Many clusters seem to be drifting toward a particular patch of sky, as if being pulled by something beyond the observable edge of the universe. They dubbed this puzzling trend dark flow. It was as though a subtle cosmic breeze were tugging on vast conglomerations of galaxies, guiding them in one direction. If true, it might imply the gravitational influence of something outside our visible universe, maybe a massive concentration of matter in the greater multiverse, or an imprint from before our universe's inflationary expansion. Imagine for a moment that dark flow is real. All around us, clusters of galaxies have a coordinated drift, like leaves carried on a vast, gentle current. It would suggest something massive and unseen lies beyond our cosmic horizon, tugging on our universe ever so slightly. Perhaps a colossal structure in a realm forever inaccessible to us is pulling on everything, or another bubble universe is brushing against ours. It's a mind-bending idea that our entire cosmic neighborhood might be in motion toward a great unseen attractor. Like a fish in a pond, unaware of the ocean beyond, we would feel only a faint hint of a larger existence outside our known world. New measurements with better data have cast doubt on the original dark flow finding. It may have been a statistical quirk or experimental artifact. Many scientists now suspect there is no significant one-way flow on those scales, but the concept lingers in our minds as a tantalizing possibility. Real or not, it reminds us of how much remains beyond our view. We peer as far as we can, but there may be more cosmos, perhaps an infinite expanse beyond, quietly influencing our patch in ways subtle and profound. While considering large-scale motions, we also encounter curious alignments on the cosmic stage. Quasars, the bright cores of distant young galaxies powered by voracious black holes, often emit polarized light, which has an orientation or angle to its waves. In a completely random universe, the polarization of quasars separated by billions of light-years should have no connection. But surveys have found that in certain huge regions, the polarization angles of many quasars seem to line up in the same direction, as if oriented by a common large-scale field. Similarly, the axes of rotation of hundreds of galaxies in enormous structures have shown hints of alignment beyond what chance would suggest. These observations hint there might be an underlying coherence over unimaginably vast distances. Perhaps threads of magnetic fields stretching across the cosmos, or subtle traces from the initial conditions of the Big Bang that set a preferred direction. It's a subtle effect, still under investigation, but it challenges the assumption that at the grandest scales, the universe has no pattern. Could it be that the cosmos has an underlying order we haven't fully grasped? It's almost as though space-time itself has a hidden grain or texture on colossal scales, and these quasars are aligning along those unseen fibers of the cosmic fabric. Another phenomenon occurs not in the alignments of light, but in echoes of light across time. Sometimes, a distant object, like a quasar or blazar, a galaxy shooting a jet of energy directly at us, undergoes a sudden flare. If there's a massive intervening galaxy cluster or a concentration of dark matter between us and that quasar, the light from the flare can take multiple paths around the gravitational obstacle. We might see the quasar brighten, then fade, and then, miraculously, brighten again months or years later, the same event's light arriving via a longer route. Nature provides a delayed replay. Astronomers have observed such light echoes with distant supernovae. A supernova's light was gravitationally lensed, producing multiple images and hence multiple arrival times. Each echo is an opportunity, like seeing the event from multiple angles. Even on smaller scales, within our galaxy, a sudden stellar outburst can reflect off interstellar dust clouds and send a later, softened echo of the flash to Earth. Through these echoes, the cosmos seems to communicate in time-delayed signals, allowing us a second look at transient events and revealing intervening structures, dust clouds, dark matter clumps, that otherwise would be invisible. We find ourselves in the quiet space between galaxies, taking in these vast patterns and subtle phenomena. Here, in intergalactic space, it is almost perfectly dark. We pause for a moment and absorb the profound quietude. It's a silence so complete, it feels sacred. With no nearby stars and no dust to catch stray light, the darkness is pure and velvety. You could reach out and not see your hand, as nothing nearby scatters starlight. The only hints of existence are the soft collective glow of galaxies clustered in the distance, and the very faint microwave whisper of the Big Bang's afterglow that bathes all of space. In this stillness, even your thoughts seem loud until you let them hush, and then you become part of the silence. We recognize how far we've traveled in our minds, from the Earth into a realm where galaxies themselves are like points of light. We think back on the journey so far, reflecting on the tapestry of mysteries we've encountered, the brief sparks and long shadows that the cosmos casts. We recall the fast radio burst, a blink and you miss it event carrying the power of millions of suns. How astonishing that something can be so brief yet so brilliant. We remember the star that winked at us in slow, irregular patterns, and how it ignited thoughts of alien megastructures, opening our minds to grand possibilities, even though dust probably weaves the tale. We drifted by a rogue planet and felt the weight of its eternal midnight, wondering if life could endure in that sunless cold. Perhaps huddled around internal fires or glowing faintly to light its own way. We saw a mighty star quietly collapse into nothingness, and realized that even destruction can happen in peace and silence. A stellar life, ending not with a bang, but a whisper. We skirted the abyss of a black hole, grappling with the strangeness of time and space at their limits, and gaining respect for the mysteries locked behind the horizon. We contemplated doorways through space-time that might connect distant realms, wormholes, fantastic and perhaps impossible, but inspiring dreams of cosmic journeys that ignore the usual rules. We peered into the bustling heart of our galaxy, finding it full of odd phenomena, gamma bubbles, antimatter flares, magnetic filaments, and stars careening under the spell of a dark giant. A cosmic city of wonders, hidden by distance and dust from our normal sight. We traced subtle patterns in the way quasars align and galaxies dance, hints that even on the largest stage there might be an order or direction imprinted from the universe's youth. And we listened to the cosmic symphony of particles and waves, the faint whisper of neutrinos arriving from a blazar's heart, the rare thunderclap of a cosmic ray hitting our atmosphere after a journey from some far-off accelerator, the background hum of microwaves filling space. Each message, whether a particle or a wave, has widened our perception. Each mystery we encountered has not only expanded our knowledge, but deepened our appreciation for the unknown. We feel enlightened because we have seen the cosmos reveal many of its secrets to those who seek them. But we also feel humbled, because for every answer, new questions twinkle, as innumerable as the stars. Before we journey to the very origin of these mysteries, let's acknowledge something quietly wondrous. It's astounding that we, small creatures on a small planet, can know about any of these distant marvels. In just a few generations, we have transformed the way we perceive the cosmos. From simply gazing up with our eyes, we have built instruments that extend our vision and hearing far beyond our natural senses. We have radio antennas that catch the whispers of pulsars and mysterious bursts, space telescopes that see galaxies forming at the edge of time, detectors deep underground that feel the flutter of neutrinos from supernovae, and observatories that measure the subtle stretching of space when black holes collide. With ingenuity and curiosity, we've made ourselves into cosmic listeners and watchers. It's as if, through our determination to understand, we have given the universe a way to know itself. Every mystery we've explored tonight was revealed to us by these extensions of our senses. From our tiny world, we reach out and intercept the songs of distant stars and the ghostly echoes of ancient explosions. In doing so, we become participants in the cosmic story, woven into the tapestry of the universe by our awareness. Now, our journey turns toward the beginning, the faint glow that fills the universe from edge to edge, the afterglow of the Big Bang itself. We direct our attention to the most ancient light we can see, the cosmic microwave background, CMB. This soft radiation comes from nearly 13.8 billion years ago, when the universe was in its infancy, about 380,000 years old. At that time, the universe was a hot, dense fog of plasma, electrons and protons and photons all jumbled together. As it expanded and cooled to a few thousand degrees, electrons settled into orbits around protons, forming the first hydrogen atoms. Space became transparent. Light could travel freely for the first time. That light, released everywhere in the universe at that moment, has been journeying ever since. Stretched by the expansion of space, it has cooled to just 2.7 degrees above absolute zero, turning into a faint glow in the microwave part of the spectrum. If we had microwave vision, the entire sky would glow with a very uniform, pale fog of light. This is the afterglow of creation, the baby picture of the cosmos. The CMB is remarkably uniform, a testament to how smoothly mixed the universe was at that early epoch. But it's not perfectly uniform. There are tiny variations in temperature, only tens or hundreds of millionths of a degree, scattered across the sky. These slight hot and cold spots correspond to regions of ever so slightly different density in the young universe, the seeds from which galaxies and clusters eventually grew. We've mapped these patterns with satellites named COBE, WMAP, and Planck, and from them we've learned the age, content, and shape of the universe with astonishing precision. Yet, even here in this most distant light, there are anomalies and puzzles. One of the most intriguing is the CMB cold spot. It's a region in the southern sky, about 5 degrees across, that is significantly cooler than the average CMB temperature by a few hundred microkelvins. That doesn't sound like much, but statistically it stands out. It's larger and deeper than expected in our standard cosmological model. When first noticed in the WMAP satellite's data, and later confirmed by Planck, it spurred debate. Could it be a random fluke, a chance low-temperature blob that, while unlikely, is not impossible? Or does it hint at something more exotic? One idea to explain the cold spot is a huge supervoid lying between us and that part of the CMB. If along that line of sight, there's a region of the universe, tens of millions of light years across, that has far fewer galaxies, and hence less matter, than average, it could affect the CMB photons that travel through it. As CMB photons pass through a large void, gravity can slightly sap their energy. A photon loses a bit of energy climbing out of the void's gravitational potential, and, because the void is expanding while it crosses, doesn't regain it all. This leaves those photons a touch colder when they reach us. Surveys have indeed hinted at a very large underdensity, a supervoid, roughly in the direction of the cold spot. If real, it might stretch about 1 billion light-years across, making it one of the biggest voids known. That could account for some of the cold spot's chill, though whether it accounts for all of it is unclear. Another, far more speculative explanation is that the cold spot is an imprint of something beyond our universe, literally a collision with another bubble universe in a grand multiverse. In the inflationary cosmology idea, our Big Bang might be just one of countless bubble universes popping off in a larger inflating space. If two universes happen to bump into each other in the distant past, it could leave a circular bruise or disturbance in the CMB. The cold spot might be such a bruise. It's a mind-boggling notion, and extraordinary claims require extraordinary evidence. So far, detailed analyses, even looking at polarization of the CMB in that region, have not found a smoking gun that confirms a cosmic collision. Most scientists lean toward the supervoid explanation, or a statistical quirk. But the door is left slightly ajar for something exotic. For a moment, let's indulge the imagination of traveling through that hypothesized supervoid in front of the cold spot. We set course for the center of this vast emptiness. As we enter, galaxies grow sparser around us. Clusters and groups fade behind. Ahead, there's hardly a galaxy to be seen. Eventually, we find ourselves in a region of nearly pure black, an almost total absence of starlight in all directions. Perhaps one galaxy visible in the far distance like a lone lighthouse on a dark sea. This void might be the loneliest place in the universe. The usual landmarks of space, galaxies, nebulae, clusters, are mostly absent. For hundreds of millions of light years, one might drift and rarely encounter a single galaxy. The darkness would be deeper than any night in any sky. Only the dim afterglow of the Big Bang, the CMB itself, fills this space, and perhaps extremely faint smears of light from the nearest void-bordering galaxies far, far away. Travelling at near light speed, it could take you billions of years to traverse this void. For most of that journey, you might not see a new galaxy. The view would hardly change. It's a sobering thought. Such immense volumes of space that are so empty. Eventually, after an arduous crossing, you would approach the far side. Galaxies would begin to cluster again. First a few hazy spots, then more, until the familiar tapestry of the cosmic web brightens the sky once more. If the cold spot's void exists, it would truly be a breathtaking expanse of nothingness, an anti-structure, as significant as a structure, a great cosmic canyon. Back to our vantage point at Earth, the cold spot remains a slightly cooler patch on our all-sky map of the CMB, quietly challenging our understanding. It reminds us that even the afterglow of creation has anomalies that we haven't fully explained. It also beckons with grand possibilities, whether that's a remarkable journey through a supervoid or the faint hint of realms beyond our own universe. The cold spot isn't the only odd feature in the CMB. There are hints that the fluctuations on one half of the sky are a bit stronger than on the other half. A large-scale asymmetry that's not expected in a perfectly random, isotropic universe. There's also an alignment in the orientations of certain large angular features in the CMB, which some playfully nicknamed the axis of evil, not out of malice, but because it defies the assumption that no direction is special. These could be flukes, or due to unaccounted systematics in our measurement. Most cosmologists suspect they don't indicate new physics, as the evidence is not extremely strong. But their presence in the data keeps us on our toes. We must remember that even in the most well-studied, smooth maps of the cosmos, we might stumble upon the unexpected. The universe, even in its baby picture, has wrinkles we are still smoothing out in our theories. Now we push even further back, to the brink of the beginning, and the tiniest scales, to times and energies where our understanding falters and wonder begins anew. To truly complete our tour of cosmic mysteries, we must face the extremely early universe and the realm of the infinitesimally small. This is the Planck era, when the universe was an almost inconceivably small fraction of a second old, and everything we know was compressed into a volume smaller than an atom. At these scales, the classical laws of physics give way to quantum uncertainty, and space and time themselves might have been wildly fluctuating, like a foamy sea of possibilities. Our current theories suggest that around this time, a stupendous event called inflation took place. The idea is that a tiny patch of the universe, containing quantum fields in a high-energy state, suddenly blew up at an exponential rate, doubling in size over and over in a fleeting instant, far faster than the speed of light, which is allowed since it's space itself expanding. This took a region perhaps billions of times smaller than a proton and expanded it to a macroscopic, perhaps cosmic size. When inflation ended, that enormous expansion dumped energy into matter and radiation, heating the young universe and leading into the more gradual expansion we see today. Why do we think this happened? Because inflation neatly explains why the CMB is so uniform. Distant regions were once close together before being blown apart, and why we see no strong curvature to space. Inflation would have stretched any initial curvature to near flatness. During inflation, tiny random quantum fluctuations, essentially the jitter of uncertainty at subatomic scales, were also stretched out. Imagine an enormously blown-up quantum foam. The little density variations became the seeds for galaxies. Inflation ended and left the universe filled with a near-uniform glow, plus slight density ripples here and there. Over billions of years, those ripples grew, gravity pulling a bit more matter into the dense spots, eventually forming the cosmic web of galaxies and voids. It's breathtaking. The largest structures in the cosmos owe their existence to microscopic quantum randomness in the first flicker of time. Yet, inflation itself is not fully understood. We have evidence consistent with it, but we don't know what field or force drove it, or exactly how it started and stopped. There are many models, inflaton fields, potential energy landscapes, but no definitive answer. And what about before inflation? Was there a before, or did time itself begin then? Some suggest inflation could be eternal in a broader multiverse context, creating bubble universes, one of which is ours, endlessly. Others propose cyclic models, where perhaps our universe periodically undergoes bounces or metamorphoses. These edges of knowledge blur into philosophy. For now, we treat inflation as a useful description that fits what we see, while acknowledging we lack details about the initial trigger and the exact mechanism. During those first moments, there are other deep mysteries. One is the matter-antimatter asymmetry. When the universe was incredibly hot and young, particles and antiparticles were being created and annihilating in almost equal amounts. They should have completely destroyed each other, leaving only light. But somehow, for every billion annihilations, a tiny bit of matter was left over without a partner. Just enough to form all the atoms in the universe today. Why did this happen? It implies a slight bias in physics. Maybe some reactions favoured matter over antimatter by an infinitesimal margin. We don't yet know the reason. It's as if the universe, in those first moments, loaded the dice in favour of matter, allowing stars, planets, and us to exist. This is called the baryon asymmetry problem. Experiments try to detect hints of this bias in subatomic processes, but the answer remains elusive. It's another reminder that the biggest questions, why is there something rather than nothing, sometimes hinge on the tiniest of differences in the laws of nature. As the universe expanded and cooled, it went through a series of transformations. Forces that are unified at high energy broke into distinct forces: gravity, electromagnetism, nuclear forces. It's like cooling a liquid into crystals. Patterns emerge. The details of these transitions might hold clues to future discoveries like magnetic monopoles or other relic particles. If any primordial black holes formed from especially overdense regions during this time, they could still be around. We've mentioned these earlier. Unlike black holes from stars, primordial ones could theoretically span a wide range of masses, from microscopic, which by now might have evaporated into a puff of Hawking radiation, to huge. So far, we haven't found definitive signs of them, meaning if they exist, they're either rare or in mass ranges that are hard to detect. But some scientists still consider if a portion of dark matter could be hidden in these old black holes. Speaking of dark matter, our universe today is dominated by it in terms of mass, about 5 times more dark matter than normal matter. Yet, we've never directly seen a dark matter particle. We just see its gravitational effects, the way galaxies rotate too fast, the way clusters bend background light more than visible matter alone would allow, the way structures formed the way they did. What is dark matter? We listed some possibilities. Perhaps it's an undiscovered particle, like a WIMP that rarely interacts with normal matter, except via gravity. Many experiments on Earth and in space are searching for faint collisions of dark matter with detectors. So far in vain. It could be something more exotic, like axions, ultra-light particles, filling space like a gentle field, or sterile neutrinos, ghostly heavier cousins of neutrinos. It might even be tied to the existence of extra dimensions or primordial black holes. Until we catch one in the act or create it in a collider, dark matter remains an open question. It's humbling that most of the matter in the universe is of an unknown type, but it's also exciting. It means there are still fundamental discoveries to be made. Let us not forget dark energy either, the even stranger component that makes up about 70% of the universe's energy content, driving the accelerated expansion of space. Discovered only in 1998, it's a kind of pressure or energy inherent to empty space, pushing galaxies apart faster over time. We don't know if it's truly constant or slowly changing, if it's a property of the vacuum or a field or an illusion, because our understanding of gravity is incomplete. but it profoundly affects the fate of the universe. If it remains constant, the universe will keep accelerating, and in the far future, distant galaxies will slip beyond our horizon, their light stretched until they vanish from view. Trillions of years hence, an astronomer in our galaxy might see only a few nearby galaxies, everything else having receded into darkness. Stars will age and die, new ones will cease to form, and the cosmos will grow cold and quiet, a fate sometimes called the heat death, an ever-dimming future where only the remnants of stars, white dwarfs, neutron stars, black holes, and diffuse matter remain, slowly disappearing on timescales we can barely comprehend. That is one possible ending, far beyond any human concern, an abstract, distant twilight of the universe. Another possibility, if dark energy isn't constant, perhaps it intensifies or changes character. In some speculative scenarios, like phantom energy, it could eventually rip even galaxies, stars, and atoms apart, the Big Rip. Or if it decays, maybe cosmic acceleration will slow or even reverse, less likely with current data, but not impossible, leading to a cycle or a collapse. At this point, we simply don't know. For now, dark energy appears consistent with a simple constant, Einstein's cosmological constant. But its true nature remains one of the deepest puzzles in cosmology. Standing at the threshold of this cosmic dawn, we find ourselves filled with wonder. We started from faint signals in the night and journeyed all the way back to the fire of creation. We confronted phenomena that challenge our understanding. Things incredibly fast and powerful, things vast and structured, and things tiny and fundamental. Each mystery remains an open question, inviting exploration. And when one mystery is solved, it often opens the door to many more questions. The cosmos seems inexhaustible in its capacity to surprise and intrigue us. Our journey of discovery has no final end. Each generation will find new puzzles to ponder, new wonders to explore. That is comforting in a way. There will always be more to learn, always new marvels among the stars. For now, we have reached a kind of cosmic bedtime. We've wandered through fast radio bursts and flickering stars, rogue planets and vanishing suns, black holes and hypothetical wormholes, galactic whispers of antimatter and alignments, cosmic microwave echoes, and primordial fluctuations. Our voyage through these unexplained phenomena is only partway done. The universe holds many more mysteries beyond the next horizon. But at this gentle hour, we can let our minds rest among the stars and galaxies we've visited. In this gentle cosmic night, we have journeyed far and wide, yet we are still the curious children of the universe, gazing up in wonder. It's all right not to have all the answers tonight. The questions will wait for us, patiently, as they have waited for ages. Tomorrow, or years, or eons from now, these mysteries will still be there to explore, and perhaps to solve. And even as we solve some, new mysteries will emerge, ensuring that the cosmic story never truly ends. Now, it's time to simply be, to let all these images and ideas settle softly in your mind. The night is deep and calm. You are drifting among the stars in your thoughts, weightless and free. The mysteries we encountered float around you like friendly phantoms. each one a point of light in the dark, each one now a gentle companion rather than an enigma. Feel the comfort of knowing that there will always be more to discover, but that you don't need to chase those answers now. The universe isn't going anywhere. Its secrets will be there when you're ready. In this moment, you can embrace the not knowing and find peace in it. Perhaps, as sleep gently takes you, you'll find yourself dreaming of cosmic journeys of your own. You might imagine walking along the rings of Saturn, feeling the fine, icy grains beneath your feet as they sparkle in starlight. Or you might float through the glowing clouds of a nebula, as if swimming in a luminous sea of colours. Maybe you'll sail on the tail of a comet, or drift beside a newborn star, listening to its quiet, newly ignited fire. In dreams, you are free to explore the universe further, in the safe harbour of your sleeping mind. Let any such visions come to you softly and carry you wherever they wish. You are free in this infinite playground, unbound by gravity or time, wandering among galaxies with the same ease as a stroll through a garden at dusk. Imagine yourself on a quiet hillside under a moonless sky. The air is cool and still. Above you, countless stars shimmer, forming a soft river of light that is the Milky Way. A gentle flash draws your eye. A meteor silently streaks across the darkness, here for a heartbeat and then gone. Its brief glow only deepens the stillness as it fades. You are lying on the warm grass, looking up and feeling the solid earth support you. As you inhale deeply, you smell the faint sweetness of night-blooming flowers and damp soil. As you exhale, you release all the tension in your body. In this moment, you are at peace. The concerns of the day feel far away, and only the present exists. You, the earth beneath, and the vast night sky above. Now, in your mind's eye, you begin to float upward. Slowly, gently, you rise a few feet, leaving the ground. The grass and trees recede below as you ascend effortlessly into the air. There is no fear. You feel completely safe and free, as if borne by an invisible loving force. Higher and higher you drift. The landscape spreads out. You see sleeping towns as tiny lights, and winding rivers as silver ribbons in the darkness. Far in the distance, near the horizon, a soft green shimmer catches your eye. The aurora borealis, dancing silently at the edge of the atmosphere. These ghostly lights sway and curl in slow motion, a final earthly enchantment as you leave the world behind. The atmosphere wraps you in a comfortable silence. Soon, you pass through wispy clouds and continue upward. The sky turns darker, the stars brighter. The curvature of the earth becomes visible, a great blue-black disk illuminated by faint starlight. With a calm sigh, you find yourself crossing into space, weightless and unbound. The earth is now a glowing ball below, and you are enveloped by the serene emptiness of space. Take a moment to appreciate this view. The earth below is beautiful and distant, and all around you is the deep, velvety black of space strewn with stars. You are floating in a cocoon of tranquility between worlds. There is no sound except your steady breathing, which echoes gently in your mind. Each breath in fills you with the cool, crisp night of space. Each breath out lets you relax even more. You feel your heart rate slow down to a peaceful, unhurried rhythm. In this state of total relaxation and wonder, you are ready to journey among the stars. Let us drift further now and explore the quiet marvels of the cosmos. In the silent darkness of the cosmos, our journey continues. Far beyond the last echo of familiar constellations, we drift weightlessly through a boundless expanse. The stars around us are sparse now, tiny pinpricks of light scattered across a deep velvet void. There is only tranquility here, a vast cosmic night, calm and eternal. As we float onward, the stillness itself seems to whisper, inviting us to explore yet deeper mysteries hidden in the starlight. After a time, a subtle presence draws our attention. Ahead, space itself appears oddly distorted, like looking through an invisible curtain. Starlight on the far side of this region bends and doubles, as if reflected in a funhouse mirror. We approach carefully, gliding closer to this strange phenomenon. There is nothing solid to see, no shining planet or nebula, only a thin line where the fabric of space is strangely tense. This is a cosmic string, a hypothetical filament left over from the universe's childhood. Imagine the early universe as a hot, stretching canvas. As it cooled and expanded, tiny imperfections might have crystallized into these ultra-thin strands. They are thinner than an atom, yet unimaginably dense and long, potentially spanning entire galaxies in length. We cannot see the string directly. It emits no light of its own, but its gravity is immense along its vanishingly narrow line. Like a hairline crack in a pane of glass, it subtly warps the space around it. As we hover near, we notice a distant galaxy whose image is oddly doubled, split into two shimmering apparitions on either side of an unseen line. The cosmic string between us and that galaxy bends the light coming around its sides, creating mirror images. It's as though the string is a gentle trickster of light, teasing us with duplicated visions of the cosmos beyond. Despite their great mass, cosmic strings are silent and tenuous. Though narrow as a whisper, the string's gravity is strong, yet so confined to its line that beyond a short distance you might not even feel its presence. We maintain a respectful distance, observing the string's effects from afar. It stretches out into the darkness beyond our sight, an impossibly straight line threading through space. We follow it for a while in our imagination, wondering where it leads, perhaps looping through the cosmos and back again, or vanishing into some unreachable horizon. As we glide alongside this cosmic filament, we ponder its origin. Some theorize that in the split second after the Big Bang, as matter and forces separated into the forms we know today, these strings froze into existence, like scars of that transition. In those first moments, the universe was like a liquid, rapidly cooling, forming cracks and faults. A cosmic string could be one such fault line, a relic of a phase change when the forces of nature were finding their distinct identities. Each string would carry tremendous energy, and though we have yet to find one in reality, it remains a tantalizing possibility, hidden in the vastness. Should a cosmic string exist, it might occasionally create a burst of gravitational waves, tiny ripples in space-time, if it oscillates or snaps a loop. Some scientists even speculate that a whole network of cosmic strings in the early universe would have filled space with a faint gravitational hum that could still be detectable today. For now, the universe keeps their song quiet, but efforts are underway to listen for this gentle chorus of space-time. Drifting further, we begin to encounter a faint, diffuse glow. starlight from a distant cluster reflecting off something broad ahead. It's not a single point, but a plane, an expanse that seems to stretch out like an enormous flat sheet in space. We realize we may be approaching another hypothesized remnant of the early cosmos, a domain wall. If the cosmos is a tapestry, a domain wall is like a seam or boundary between patches of different patterns. Long ago, if the universe underwent a profound change, flipping some fundamental quality of space, regions that made different choices could be separated by vast walls of energy. We edge closer to this invisible wall. There is still nothing to see directly, but its presence is felt in the way background starlight vanishes beyond it, or how the faint glow of galaxies behind it dims and reddens. Perhaps the physics on the other side of this domain wall are slightly different, making light travel ever so differently. We imagine what it might be like to cross this boundary. Would the rules of nature feel altered by a tiny fraction? On this side, an electron's charge and mass are as we expect. On the far side, could they be just a hair's breadth different? The idea sends a shiver of awe through us. Here could lie a partition between slightly different universes, coexisting side by side. Much like a cosmic string, a domain wall would have emerged in the tumultuous moments after the Big Bang. Think of the early universe as froth with bubbles, each bubble a region where a certain property took a specific value. Where bubbles met, if their properties differed, a domain wall would form at the interface, a stretched membrane of energy marking the divide. Most of these bubbles likely merged, or the walls collapsed as the universe settled into a more uniform state. But perhaps one or two walls survived, drifting through intergalactic space, enormously large, yet incredibly thin. They would be like sheet ghosts of that primordial time, nearly undetectable, except for subtle gravitational effects. We float face on to the wall now, letting ourselves become parallel with its plane. It's mind-boggling to imagine. This wall might extend for light years in every direction, yet be no thicker than a subatomic particle. We might pass through it without incident, one moment in one domain, the next moment in another, hardly noticing except for the faintest change in some fundamental cosmic note. If we listen carefully with our imagination, we almost sense a change in the cosmic background hum as we slip through, a gentle sigh as one reality transitions into its mirror version. Passing beyond the domain wall, we glance back. The wall itself is still invisible, a quirk of space rather than an object. But we mark its presence by the slight bending of light and the way it divides the starry field, like a nearly transparent curtain across the sky. It's tranquil on both sides, just ever so subtly different. Perhaps, on the other side, if we had sensitive instruments, we might measure that the spectrum of a distant quasar has tiny shifts, hinting that the constants of nature there are not exactly the same as here. Such differences would be minute and gentle, yet profoundly intriguing. They whisper that even the so-called constant laws of physics might have variety across the cosmos. Aware that we have just traversed a boundary few have even dreamed of, we continue our voyage, leaving the silent domain wall and the slender cosmic string behind. We venture onward into open space again. The stars ahead shine with a familiar light, as if welcoming us back into the physical regime we know. Yet we carry with us the wonder that there may be places out here where reality itself has more than one setting, more than one way to be. The existence of cosmic strings and domain walls in our thoughts reminds us how delicate the cosmos's fabric can be, and how many secrets might be woven into its weft and warp. The emptiness before us now feels full of potential. Any direction we look could hide another marvel, an undiscovered phenomenon, or a new twist on the laws of nature. Our path next leads us toward a massive, solitary sentinel deep in the void, a place where space and time themselves are twisted into unfamiliar shapes. From afar, we see the dim silhouette of a black hole, an abyss of gravity, patiently spinning in the darkness. This will be our next destination, a realm where time strays from the straight path and begins to curve and swirl in strange ways. With calm curiosity, we set our course for the black hole's vicinity, ready to explore the gentle oddities of time and space that awaken in its presence. We approach the black hole gradually, careful to remain at a safe distance. At first, it is just a patch of deeper night against the stars, a circular absence where no light returns. Around its edges, however, something beautiful reveals itself. A delicate halo, a ring of light formed by stars, far behind the black hole whose images are bent into a curve. This gravitational lensing paints a surreal outline around the darkness, as if the black hole wears a crown of distant galaxies. The effect is subtle and ghostly. We drift closer still, and the ring becomes brighter, more pronounced, a softly glowing loop encircling the void. Now we begin to feel the influence of the black hole's rotation. This is no ordinary black hole, but a spinning one, turning about its axis like a silent, massive top. As it spins, it drags the very fabric of space-time around with it. We notice that our motion is no longer entirely our own. Space itself is carrying us in a grand, slow swirl around the black hole. It's akin to a calm whirlpool in a dark ocean, utterly soundless in the vacuum of space. If we float in the water, the current will gently pull us around in circles. Here, the water is space-time, and we are caught in its smooth, inexorable flow, orbiting the black hole, not because of rockets or engines, but because space is moving. This frame dragging, as physicists call it, is usually infinitesimal around smaller objects. Even a spinning planet drags space just a little. In fact, a satellite experiment called Gravity Probe B confirmed this minute frame dragging effect around Earth, detecting a slight twist in space-time caused by our planet's rotation. But near a rotating black hole, the effect is profound. We find ourselves in a region where nothing can remain completely still. To hover motionless relative to distant stars is impossible here. Space is swirling too strongly. If we tried to resist, we would feel nothing tangible, yet we would still be carried eastward around the black hole, like a leaf in a slow eddy. So we surrender to it, letting the flow of space-time guide us. It is a serene motion, a gentle ride on an invisible carousel at the edge of a void. As we circle, we notice time itself behaving strangely. Our clocks, had we brought any, would no longer agree with clocks far away. Deep in the gravitational well of this massive object, time runs at a different pace. Each second for us stretches out longer compared to a second measured back in interstellar space. We are in a realm of time dilation, where the strong gravity and the warping of space-time make moments languid. There is no abrupt sensation to this. Nothing obviously changes in our local flow of time. But if we could peek out and compare, we'd see the outside universe racing ahead. A distant observer might watch us and think we are moving in slow motion, our actions drawn out, our orbit taking ages, while for us only minutes pass. This gentle discrepancy in the passage of time feels oddly comforting in a way. Here at the black hole's fringe, one could imagine lingering for a while, and upon returning to the outside universe, eons might have passed. It is a place where the normal rules of yesterday, today, and tomorrow blur. There's a sense that this black hole guards a deep stillness at its heart, a place where time nearly stands still, at least from an outsider's view. And indeed, if we gaze toward the event horizon, that point of no return around the black hole, we see any bits of matter that have wandered too close appear to hang suspended there. A small fragment of cosmic dust drifting inward seems to slow and fade, redder and dimmer, as if frozen on the horizon's edge. In truth, it likely fell inside long ago, but the last light it emitted is taking an exceedingly long time to escape the clutch of the black hole's gravity. We keep our distance, not venturing too near that silent border. Instead, we marvel at the phenomena around us. The space we are in, just outside the event horizon, is called the ergosphere, a region where space-time's rotation is extreme. Within this zone, even light cannot stand still. Any light beam, no matter how it tries, will be dragged around the black hole. If we shine a flashlight straight ahead, the beam curves and sweeps around to the side, carried by the rotating space. It's as if we are inside the gears of a great cosmic clock, where space and time are interconnected wheels turning under the power of the black hole's spin. Yet there is quiet here. Nothing violent or chaotic in our present orbit. The rotation is steady and smooth. We drift as in a slow-motion dance around an unseen center, feeling the subtle tug that compels us onward. Above us, the stars, we knew, have taken on unusual positions. Some appear smeared into arcs. Others seem to dance around in small loops due to the gravitational lensing and the frame dragging combined. It's a dizzying spectacle if one looks too closely, but if we relax our gaze, it becomes a softly blurred tapestry of light, wrapping around the black shadow at the center. The universe beyond the black hole is still there, but the spinning gravity lens has turned it into a swirling mural, like oil paints gently swirled on a canvas. Occasionally, perhaps, a particle or bit of gas from afar strays into this region and gets caught. We see a faint streak of light, a small comet-like glow, as some wayward material spirals inwards, heating up ever so slightly as it joins the dance. It is not a bright accretion disk, as one might find around an actively feeding black hole, but just a lone traveller succumbing to gravity. It paints a delicate spiral of light that slowly fades as it descends, vanishing as it approaches the horizon, its light stretched to invisibility. The black hole quietly grows by that tiny amount, and space adjusts to the new mass, but we are too far to feel any jolt. Everything here is gradual and smooth. We take a moment to reflect on what we are experiencing. Here we have a cosmic phenomenon that challenges our intuition. A whirlpool with no water, a clock that doesn't tick uniformly for all, a place where moving in a straight line can land you circling the same spot indefinitely. Yet, it's all a natural consequence of gravity and rotation, taken to an extreme. It reminds us that space and time are not rigid, unchanging backdrops. They are malleable, capable of bending, twisting, and slowing. In the embrace of the black hole's gravity, we feel this directly, not as menace, but as majesty. Gradually, we decide to slip out of the black hole's immediate grip and continue on our voyage. We gently fire imaginary thrusters or simply will ourselves outward, and slowly we spiral away from the dark giant. The frame-dragging current releases us back into calmer waters of spacetime. The ring of distorted starlight contracts and then vanishes as we retreat, and soon the black hole is once again just a dark spot behind us, receding into the endless night. We carry with us a newfound appreciation for time's flexibility and space's fluidity. Having seen time stretched and space spun into a vortex, we turn our minds to another subtle mystery of the cosmos. The possibility that the fundamental constants and laws we take for granted might themselves shift in the vast expanse. Are the rules of nature truly universal and fixed, or do they too whisper of change in far-flung corners of reality? With this question guiding us, we set our course toward the distant light of ancient stars, looking for clues in the cosmic symphony, for any notes that sound just a little off-key. Out in the open, galaxy-studded space, far from any intense gravity, the laws of physics return to their familiar form. We drift onward, our senses attuned now to the subtle fabric of reality itself. After witnessing space-time twisted and time stretched by the black hole, a thought lingers. What if the very constants of nature, the fundamental settings of the cosmic game, are not the same everywhere or every when? We decide to investigate not by visiting a place, but by listening to the ancient light that reaches us from the far corners of the universe. High above the galactic plane, we find a tranquil spot between distant clusters where the starlight is dim and the cosmic view is clear. Here, like cosmic archaeologists, we examine the faint light from quasars and galaxies billions of years old. This light has travelled across eons to reach us, carrying with it information about the conditions long ago. Spread out the light into a spectrum, and it becomes a rainbow barcode, a pattern of lines imprinted by atoms it encountered on its journey. Each chemical element leaves its mark, dark lines where it absorbed certain frequencies, and those lines appear at specific positions determined by fundamental constants: the mass of the electron, the strength of the electric force, the speed of light. We gently sift through this starlight, as if listening to an ancient melody. In most cases, the tune is just as expected, the same physical notes we know today. But every now and then, we find a note that sounds ever so slightly off-key. A spectral line from a distant cloud of gas is shifted by a minuscule amount, more than can be explained by the cosmic expansion's redshift alone. It's as if the atom that absorbed that light had a different idea of what the rules should be. In fact, some observations of extremely distant quasars have hinted at such differences. A key spectral fingerprint shifted by just a few parts in a million, as if the fine structure constant, which governs the electromagnetic interaction, was ever so slightly different back then. These results remain tentative and debated, but they excite the imagination, suggesting the cosmic tune may indeed have modulated over time or space. The thought is mesmerizing that the fundamental constants might not be absolutely constant. The fine structure constant, for instance, which dictates how electrons dance around nuclei and how atoms absorb light, might have been marginally different in the remote past or in another region of space. Imagine this number, a delicate ratio that governs the structure of atoms, being a tiny bit higher or lower. The difference would be imperceptible to any beings of that time. It wouldn't suddenly make atoms fall apart. But across billions of years of light travel, our precise instruments could tease out that slight change, like detecting a single altered violin note in a grand orchestra. We float in this idea, recalling that physics, as we know it, is built on a set of deep-rooted numbers: the charge of the electron, the strength of gravity, the speed of light, and others. They seem woven into the universe's tapestry, the same everywhere we look, producing the same hydrogen atoms in distant galaxies as in our own bodies. Yet, the universe is vast in space and time. Could there be patches where the weave is just a bit different, where those threads are tighter or looser? If the cosmos is a grand quilt, maybe not every patch is identical. Pointing our attention in one direction of the universe, we sample many distant sources and find those spectral lines hinting at one value for the electromagnetic strength. Then we turn to another far-flung direction and notice the hints might be different. Perhaps in that opposite quadrant of the sky, the electromagnetic tune is pitched slightly higher or lower still. The data is subtle, barely above a whisper, and scientists on Earth debate whether it's real or just noise. But for our meditative journey, we entertain the possibility. What if the universe has a gentle gradient, a hidden pattern where the laws shift from one cosmic locale to another? It could be that in the deep past, right after the cosmos was born, these constants were not set in stone, but were still settling, like cooling metal that very gradually contracts. Or perhaps some unknown field pervades space, altering the constants by tiny degrees in different regions. A field we've yet to identify, a kind of cosmic background field, influencing the fabric of physics itself. The specifics are unknown, but the poetry of the possibility washes over us. We imagine travelling to a far galaxy and conducting an experiment, only to find the results differ slightly from what we predict with Earth's physics. It would be like discovering a new dialect of a familiar language, recognizable, but with a few words pronounced differently. However, if such differences exist, they are extremely small. The universe clearly operates with great consistency, or else the stars in that distant galaxy would not live and die in ways we largely understand. So any changes in the constants must be very gentle drifts, like a slow change in tempo that only becomes noticeable after a long symphony. This is a comforting thought. The cosmos, even in its mysteries, maintains a kind of reliable harmony. Still, within that harmony there may lie subtle variations, secret verses in the cosmic song. As we let this possibility settle in our minds, we look again at the stars around us with renewed wonder. Perhaps somewhere out there, in an unseen corner of the cosmos, the light is shining with slightly different rules. Stars burning a little hotter or cooler because one of nature's numbers is tweaked. The differences would be slight, but meaningful, hinting at layers of complexity beneath what we consider immutable. It reminds us that our knowledge, though profound, might be locally tuned, and the universe could be playing a more elaborate melody than we realized. And somehow, that thought is comforting, that even the laws of physics have their subtle variations, as if the cosmos enjoys improvising on its own themes. Contemplating these delicate anomalies in the fundamental constants, we feel a sense of humility and awe. The universe is not a rigid machine, but a living, evolving mystery, one that might have room for flexible rules. We drift onward, carrying this thought gently, our minds open to whatever subtle variations reality might hold. And as we do, another notion forms, one closely related to these hidden influences, a question of whether there could be entire realms of matter and existence that are hidden from us, like a mirror reflecting our universe in secret. Could there be a whole mirror world made of elusive particles, silently coexisting with our own? Intrigued by this prospect, we set our course toward the idea of mirror matter and the hidden symmetries that might underlie the cosmos. we begin to explore this intriguing possibility of a hidden mirror world. Unlike our previous travels, this journey is not so much through physical space as through a conceptual veil. We imagine peeling back the visible layers of the universe to peer at what might lie beneath, or perhaps alongside, them. In our mind's eye, we hold up a mirror to nature and wonder if something gazes back from the other side. Picture, if you will, an entire cosmos parallel to our own, composed of mirror matter. Every particle we know, electrons, protons, neutrons, would have a mirror twin. These mirror particles would behave among themselves with the same complexity and richness as our familiar matter does. There could be mirror hydrogen atoms, mirror stars fusing mirror helium, even mirror galaxies congregating in clusters. Yet, because mirror matter interacts with our matter only through gravity, and perhaps through the weakest whisper of other forces, if at all, this entire mirror universe would be essentially invisible to us. It would be like a ghost overlapping our reality, present in the same space but never touching, save for the subtle pull of its gravity. Drifting through the cosmic dark, we entertain the notion that right here, where we float, there might also be mirror particles passing through us, as if we weren't even here. And likewise, our atoms pass through them without collision or recognition. We and the mirror world are like two superimposed images on a photographic film that don't interact. Only gravity, the universal shape of spacetime, is felt by both. So if a great cluster of mirror galaxies lies in one part of the cosmos, our normal galaxies would feel its gravitational presence, moving slightly faster or bending their paths as if influenced by an unseen mass. This provides a tempting explanation for a long-standing cosmic mystery: dark matter. Perhaps some portion of that hidden mass holding galaxies together is not exotic new particles after all, but rather this shadow world of mirror matter, weighty and pervasive, yet completely transparent. As we ponder this, we imagine for a moment the Milky Way in two incarnations, one made of the stars and nebulae we see, and another, its mirror counterpart, made of unseen mirror stars. These two galaxies share the same space, swirling together like interleaved spiral arms. Yet the stars of one pass through the vast spaces of the other, without a single collision, like ghosts intermingling. Our sun might have a mirror sun accompanying it, an Earth a mirror Earth, both orbiting in tandem through the galactic center's pull, each unaware of the other. The mirror Earth would be dark to us. No light or electromagnetic radiation betrays its presence. But if we set sensitive instruments to measure gravitational effects, we might detect tiny anomalies, extra tugs and wobbles that hint something unseen is there. This concept of a mirror world arises from the idea of symmetry. Nature often displays deep symmetries. For every particle with a given property, there might be another with a mirrored property. We see hints of this in antimatter. Each particle has an antiparticle of opposite charge, or in the symmetry of forces. But antimatter we can detect. It interacts and annihilates with matter in flashes of energy. Mirror matter is a more hidden symmetry. Every property has a counterpart, but in a sector that rarely interacts with ours. It is called mirror because it essentially flips certain fundamental qualities. For instance, the left-handedness we observe in some particle interactions, where nature seems to favor left over right, would be balanced by right-handed interactions in the mirror world. In that way, the mirror world would restore a balance, making the laws of physics overall symmetric if we consider both worlds together, even though each world by itself seems to violate that symmetry. We contemplate how elegant that would be. A cosmos where all the deep equations come out perfectly symmetrical, because what's missing or lopsided in our visible world is completed by the invisible mirror side. It's like hearing only one part of a duet. The melody sounds incomplete until the second voice joins in from the shadows, harmonizing in perfect symmetry. This notion adds a sense of completeness to the universe, even if the mirror component is elusive. Is there any way for us to know if mirror matter truly exists? Directly, it is nearly impossible to see, by definition. Yet, perhaps there are rare portals of interaction. Some have speculated that if a mirror and normal particle mix a little through some subtle process, there could be faint signals. Maybe a particle unexpectedly vanishes from our world, slipping into the mirror realm, or an unexplained appearance of energy as something transitions between sectors. It would be exceedingly subtle, like a barely audible note in a quiet room. Scientists have searched for such hints in laboratory experiments and in observations of cosmic rays or decays of particles, but so far nothing conclusive has surfaced. Still, the absence of evidence does not quench the allure of the idea. In a universe so vast and old, who's to say we've looked under every rock or listened to every whisper? We consider gravitational waves, the ripples in space-time caused by massive objects moving. If two mirror neutron stars collided in the mirror universe, they would create ripples in space-time that our detectors might sense, even though we'd see no flashing merger in electromagnetic signals. It could be like hearing a faint drum beat with no visible drummer. Perhaps one day, an observatory will pick up a gravitational wave event that cannot be paired with any visible source, hinting that the source was something in the mirror sector. That would be a breathtaking clue. For now, mirror matter remains a beautiful hypothesis, a cosmic possibility that tickles the imagination. It invites us to think of reality as multi-layered. What we see is not all that exists. There could be entire worlds, as real as our own, stacked in the same spatial volume, each following its own version of physical law, interacting only in subtle ways. The mirror world, if it's there, is a silent partner to the dance of galaxies. Maybe it contributed to the formation of structure in the universe, its gravity helping to shape the distribution of galaxies we observe. And yet it stays forever in the background. The idea of hidden symmetries extends beyond just mirror matter. Some dream that every force we know might be part of a larger symmetric pattern, like notes in a chord. We have hints of this in our equations. Electricity and magnetism unify beautifully, and further, the electroweak theory shows how two forces were once one in the early universe. Physicists wonder if a grander unification exists, tying even gravity into a symmetric bow with the other forces, or if every particle we know has a partner, as in supersymmetry, another kind of mirror pairing involving force carriers and matter particles. These ideas all point to an underlying order, an elegant simplicity behind the complexity that we have only glimpsed. They remain hidden in the high energies of the early universe or in mathematical beauty, waiting for evidence. As we float through the darkness, considering these possibilities, we feel a sense of deep calm. The universe, in all its enormous mystery, might be fundamentally balanced in ways we can barely perceive. Even if we never see the mirror world or the perfect symmetry directly, the possibility of its existence is oddly comforting. It would mean the cosmos has a hidden balance, a silent partner to the world we see, providing a reassuring sense of completeness. In a universe so vast, the thought that it might have a reflective twin is pleasing, as if the cosmos ensured it would always have a companion, an unseen friend dancing in parallel. It's as if the cosmos has secret compartments, and just imagining them enriches the experience of the journey. Gradually, our attention turns from this invisible, hypothetical mirror realm to another kind of mystery, one that deals with information itself. We've pondered hidden matter and shifting constants. But what about the information carried by all the particles and fields? What happens to the information about objects that disappear from our view? This leads us gently to the famous puzzle of information in the universe, exemplified by black holes, but extending beyond them. The question of whether information is ever truly lost or merely transformed. With curiosity still aflame, yet our minds remaining unhurried, we set our thoughts on this information paradox, and the subtle ways the cosmos might preserve or conceal knowledge of all that has ever been. We turn our thoughts to the idea of information in the cosmos, not the kind of information we send in messages, but the very information that defines physical objects, the arrangement of particles, the quantum states, the essence of what and where everything is. In everyday life, information seems to be preserved. If something changes form, we believe its details are still there, just rearranged. But black holes challenge this notion. When an object falls into a black hole, carrying intricate information, perhaps the detailed pattern of its atoms, the unique configuration of its matter, it appears to vanish behind the event horizon. To an outside observer, all that remains evident is the object's mass, and maybe its charge or spin added to the black hole. The rich detail of what it was, its information, seems to be swallowed and locked away forever. This is the famous black hole information paradox. According to quantum physics, information cannot simply be destroyed. The universe, at a fundamental level, should keep track of all processes, even if they're scrambled beyond recognition. Yet, a classical black hole, with its one-way boundary, seems to erase information from our universe once something goes in. It's like a secret being lost to an impenetrable vault. Stephen Hawking's groundbreaking work showed that black holes aren't completely black. They emit a faint Hawking radiation over immense timescales, slowly evaporating away. But this radiation, as first understood, appeared random, carrying no imprint of what fell in. If that were true, when a black hole completely evaporated, the information about everything that ever fell into it would be gone from the universe, violating quantum rules, a profound mystery. We float in thought, just outside an imaginary black hole's horizon, considering the fate of a lost letter thrown into it. Does the universe truly forget the letter's contents? Or is there a secret ledger where the information is kept? Many believe the latter, that somehow nature finds a way to preserve the ledger. One compelling idea is that the information is not lost at all, but stored on the black hole's event horizon itself, encoded in microscopic details, like a hologram on the surface that holds all the particulars of what has fallen in. Indeed, physicists refer to this idea as the holographic principle, indicating that the information in a volume of space can be represented on its boundary. In this view, the Hawking radiation that eventually leaks out isn't just random. It's subtly correlated, carrying away the information in a highly scrambled form. To any practical being, that information is as good as lost. Unscrambling it would be practically impossible. But in principle, it isn't destroyed. The universe's law that information is never truly wiped out would hold. We let this comforting possibility wash over us. Nothing is truly forgotten by the cosmos. Every particle that falls into a black hole leaves a trace, however faint, and the black hole's final whisper of radiation carries away the essence of all it consumed back into the wider universe. The paradox, then, could be resolved not by violating quantum rules, but by an unexpected twist. That a black hole's surface is like a memory device, a cosmic chalkboard, where information is smeared in illegible script, yet present. Expanding our view beyond black holes, we realize this idea has even broader implications. It hints that the universe might be holographic in nature, that all the information within a volume of space could be encoded on the boundary of that region. Think of the observable universe itself. It has a horizon, a limit beyond which light has not had time to reach us in the age of the cosmos. That horizon is a spherical shell, about 46 billion light-years away in every direction, though continuously receding as the universe expands. Some physicists draw parallels between this cosmic horizon and a black hole's horizon. They suggest that information about events beyond our view might still be somehow encoded on the boundary of our observable universe, maintaining a cosmic ledger of sorts. If true, it would mean the universe fundamentally stores information in a distributed way, not just at the locations where things happen, but also on the edges of space-time regions, ensuring that no information is irretrievably lost, only out of reach. Contemplating this, we imagine the universe as a grand library. In its vast halls, every event, every particle's quantum state, is like a book on a shelf. When something falls out of our sight, behind a horizon or into a black hole, it's as if that book is moved to a higher shelf. We down below might not be able to reach or read it anymore, but it's still there, recorded in the library of the cosmos. Even if we cannot recover the story, the pages are not burned. In the far future, if black holes evaporate, or if someone could read the subtle patterns on horizons, the information could, in theory, be pieced together. There's a gentle reassurance in this view of the universe, a kind of cosmic conservation of memory. We take comfort in the idea that the patterns of existence, those we witness and those we don't, are never utterly erased. Instead, they transform, migrate, and disperse, but remain part of the fabric of reality. This principle might extend beyond black holes and horizons to all processes. Perhaps even when particles collide and produce entropy, disorder, the information is still there, woven into the correlations between the outgoing fragments. Our journey through the information paradox thus leaves us with the realization that destruction might be an illusion. It may be only a dense fog of complexity that hides information from our eyes. In the end, the cosmos could be an endless archive, preserving the imprints of all happenings in codes we've yet to fully decipher. Buoyed by this thought, we drift onward. The notion of a holographic universe and hidden information resonates with the sense that the cosmos has many layers of truth. We have touched on hidden worlds and secret records, and now our path naturally leads to the evidence the universe gives us of its own deep past. In the silence of space, faint signals from long ago continue to echo. It is time to follow those ancient light echoes and seek the galactic fossils that linger as clues to epochs gone by. These soft echoes and remnants will guide us further, gently illuminating the dark and quiet reaches of cosmic history. Guided by the idea of cosmic memory, we seek out places where the universe's past still softly illuminates the present. One such phenomenon is the light echo, where a flash of brilliance from long ago finds new life by reflection. We carry ourselves to a quiet, dark nebula on the fringe of a distant star cluster. This cloud of interstellar dust has drifted undisturbed for ages, cold and lightless, like a slumbering phantom. Suddenly, as we watch, the nebula begins to glow with a gentle, ephemeral light. Not from within, but as if illuminated by an unseen lantern. What we are witnessing is the echo of a stellar eruption that occurred many years before. Perhaps a decade ago, deep in the heart of that star cluster, a star underwent a sudden outburst. A nova, or a stellar flare, releasing a brilliant flash of light. That initial flash travelled outward in all directions. The direct light may have reached telescopes back on Earth years ago, announcing the event. But some portion of the light took a longer path, journeying outward until it encountered this distant dust cloud. Now, after a delay, it scatters off the dust and finally reaches our eyes. We see the nebula come alive with concentric rings of illumination that expand outward over time. A halo of light growing and fading, the delayed reverberation of the star's ancient song. Such light echoes are not just theoretical. Astronomers have observed them in recent times. The eruption of a star in 2002, for instance, produced expanding rings of illumination through its surrounding nebula that were captured in photographs over subsequent years. Even supernovae from centuries past, noted in historical records, have been studied anew by catching their faint echoes in distant dust clouds, allowing modern science to revisit events long after their direct light faded. We float amid this ghostly display. The dust cloud around us is gently lit in a bluish hue, as interstellar dust tends to scatter blue light. We see filigree patterns, a lattice of darkness and light, as the rays thread through denser and thinner patches of the nebula. It's like watching the afterglow of a sunset on clouds long after the sun has dipped below the horizon. In the vast emptiness, this single flash finds a way to persist, giving us a second chance to witness an event already past. The effect is peaceful and profound, a reminder that light, once emitted, continues on its journey potentially forever, and given the right conditions, it can resurface as an echo far from its source and long after its time. This is cosmic memory, in a very literal sense. The nebula we're in now holds the memory of that star's outburst, and it releases that memory slowly, over years, in these glowing rings. Eventually the light will disperse and the nebula will fall dark again, returning to slumber. But for this moment, we witness time spread out and replayed, the past reaching into the present in the most delicate way imaginable. Our journey continues as the echo fades, and we turn to another kind of cosmic memory. The remnants of structures from ages past, the galactic fossils that populate space. We set course for the halo of a large galaxy, a realm far above the flat disk of bright starry spiral arms. Out here, the night is even more still and sparse. We find a stream of stars, faint, arcing across the galaxy's outskirts in a tenuous bridge of light. These stars are not part of the main spiral. They drift in a more diffuse, river-like flow. This is a stellar stream, the remnants of a smaller galaxy that long ago strayed too close and was gently pulled apart by the gravity of the larger galaxy. Over billions of years, the stars of that once small galaxy have wrapped around the larger one in a tidal stream. It's a beautiful, ghostly structure, like a gossamer ribbon of stars, wrapping the galaxy in a loose embrace. Up close within the stream, we see stars that are a bit different from those in the galaxy's disk. Many are old, with very low metal content, indicating they were born in a smaller protogalaxy early in cosmic history. They are, in essence, fossils of that consumed galaxy, still traveling in their ancient orbit as a coherent group. The bigger galaxy has incorporated their mass, but the stream remains as an archaeological trace of the event. It poses no disruption now. It's a gentle memory in the galaxy's architecture. We glide along this stellar stream, imagining the time when it was a living galaxy on its own, a gathering of stars, perhaps with its own nebulae and planets. In those days, an observer in that galaxy would see the giant neighbour dominating their sky. Gradually the two danced together, and the smaller one surrendered its stars to the larger. But nothing is truly lost. The stars live on, and the pattern of their new orbit etches a story in the sky that astronomers billions of years later, like ourselves now, can read. It's as if the big galaxy carries scars that have healed into gorgeous patterns, rather than wounds, cosmic kintsugi, where the cracks are filled with the gold of starlight. Not all galactic fossils are streams. Some are compact, globular clusters, for instance, hover around galaxies like bees around a hive. These spherical swarms of hundreds of thousands of ancient stars are relics from the early epochs of galaxy formation. We visit one in our mind, a globular cluster drifting high above the galactic plane. It is densely packed at its core with old, reddish stars. These stars have been burning for perhaps 12 billion years, almost as long as the universe has had stars at all. The cluster itself may be a survivor from the young galaxy's wild childhood, or even the remains of a tiny galaxy consumed long ago, now just a tight ball of stars left orbiting alone. In their collective glow, we see a fossilized piece of cosmic history, a snapshot of what star populations looked like eons before our sun existed. There are even larger scale fossils, entire galaxies, faint and diffuse, that appear to be nearly starless halos or the stretched out outlines of ancient mergers. Some galaxy clusters have what's called a fossil group, essentially one giant elliptical galaxy at the centre and hardly any peers, suggesting that long ago all the galaxies in that group merged into one, leaving a solitary titan as the final relic of a once crowded family. The evidence of those past galaxies is in the extended halo of stars and a pervasive X-ray glow of heated gas. These too are traces of history written in light and matter. As we explore these various remnants, a gentle realization dawns. The universe archives its story in many forms. There are the direct light echoes, playing events back for us like a cosmic recording, and there are structural echoes, like streams and clusters, preserving the outcome of events across billions of years. Even the very cosmic background radiation, the faint afterglow of the Big Bang, is a kind of fossil imprint of the universe's infancy, a baby picture of everything when it was only 380,000 years old. That glow still surrounds us everywhere, an all-pervading memory of the beginning. We will, in time, drift our attention to that primordial light to explore the subtle anomalies hidden within it. For now, floating here among the halo stars and ancient clusters, we feel connected to deep time. We see that the cosmos does not forget easily. It keeps junctures and transformations recorded in subtle ways. The faintest glow, the loosest collection of wandering stars, can serve as a monument to something that happened long before creatures existed to observe it. It's a quiet testament to continuity and change all at once, a reassurance that even as time marches on, traces of the past remain softly etched in the present. Having appreciated these luminous echoes and fossils, we gently turn our minds to another wondrous idea, one that connects not events across time, but particles across space. The phenomenon of quantum entanglement beckons, a counterintuitive link between far-flung objects, as if the universe built secret bridges between them outside the normal flow of space and time. We leave the realm of starry relics and drift into the realm of the very small and subtle to contemplate how two particles light years apart might still share a single, unified quantum whisper. Leaving behind the grand scale of galaxies, we now descend into the microscopic realm, where another mystery awaits. Here, within the quantum world of particles and photons, there is a phenomenon that seems to defy our everyday notions of space and distance. It's called quantum entanglement, a linkage between particles so deep that they effectively share the same existence, no matter how far apart they are. We imagine two photons born together in the fiery heart of a star, or perhaps in a lab where a single photon is split into two. At the moment of their creation, they are entangled, meaning their properties are intertwined. If one photon is polarized a certain way, the other will be polarized correspondingly to maintain a balance. Now suppose these twins part ways. One photon travels off toward a distant nebula, and the other heads in the opposite direction, eventually passing by us. They may be light years apart, each flying through the cosmos on its own journey. Yet, if we gently catch the photon that comes our way and measure its polarization, at that instant the photon near the distant nebula will take on a corresponding state, as if it instantly knew about our measurement. It's as though some invisible cord connects them outside the reach of normal space and time, allowing them to stay in lockstep. This correlation occurs with no exchange of signals, at least none that we can detect or that obey the speed of light limit. It is important to note that we cannot use this effect to send a message or energy faster than light. In a sense, the universe preserves causality by making the outcomes fundamentally random and only correlated once compared. But the sheer fact of the correlation, emerging no matter the distance, is astonishing. Einstein himself was deeply perturbed by this idea, famously dubbing it spooky action at a distance. Spooky it may seem, but it is very real. Countless experiments have verified entanglement, from photons in laboratories to pairs of particles exchanged between satellites and ground stations, separated by hundreds of miles. Each time, the result is the same. Measure one, and the other's state is instantly set, as if the two share a single fate. We drift in our thoughts, imagining a little story to make this tangible. Suppose two close friends prepare a pair of entangled particles in a special state, and then part ways. One friend stays on Earth with her particle, and the other boards a spaceship and travels to a star many light years away with his. Years pass. At a predetermined moment, each friend decides to measure their particle. Neither expects to send a signal by this. It's just a synchronized act. The friend on Earth observes her particle's property, say its polarization or spin, and notes the result. Light years away, at that same moment, the other friend measures his particle. Later, when they reunite or communicate via normal means, they compare notes and find that their measurements were perfectly correlated, or opposite, depending on how they set it up. It's as if, in the very act of measurement, a connection danced between the stars to ensure their outcomes were linked. They couldn't use it to transmit a message faster than light, but the pattern in their data reveals the hidden coordination, Such a scenario, though simplified, captures the essence of entanglement's mystery. We marvel at how far this entanglement could go. Could one particle here on Earth and another in a galaxy billions of light years away be entangled? In principle, yes. Distance does not weaken the entanglement. It's like a universal truth they both uphold. If you were to take one member of an entangled pair to the Andromeda galaxy and keep the other on Earth, when you checked one, the other's state would be decided in that very moment. It's as if, in some higher dimensional sense, the two particles are adjacent, even though in our space they are absurdly far apart. The cosmos might have threads running through it that tie distant points together. Threads we only see when we perform these delicate quantum experiments. We find a poetic comfort in this idea that separation is an illusion in some respects, and that at a fundamental level the universe is more unified than it appears. Particles that shared an origin remain connected no matter where they go. It makes us wonder, since every bit of matter in the universe originated from the same primordial fireball of the Big Bang, could it be that on some level, everything is faintly entangled with everything else? Over time, interactions with the environment likely broke most of those specific correlations, but one can't help imagining a cosmic tapestry where threads of entanglement weave through the fabric of space, linking distant stars and galaxies in subtle, unseen ways. Some modern thinkers have even proposed that these entanglement connections might be analogous to tiny wormholes linking the particles, a curious bridge between this quantum mystery and the geometry of space-time itself. In that picture, the mysterious instant connection isn't happening through some violation of physics, but through a hidden tunnel of sorts, a shortcut in space-time folded in upon itself. Whether or not this interpretation holds any truth, it's a fascinating convergence of ideas, that the quantum threads binding two particles could literally be threads of space-time. We envision for a moment what it would feel like if we ourselves could be entangled with another conscious being across the galaxy, sharing a state without exchanging any signals, just knowing each other's essence without words. Of course, with complex objects like people, such quantum purity is hopelessly lost in noise. But on the level of fundamental particles, the universe allows this delicate bonding, almost like a silent telepathy between them. As we reflect on entanglement, the feeling it evokes is not one of horror at the strangeness, but of awe at the profound interconnectedness that nature permits. It hints that space might not be as forbidding a separator as we think. The paradox of distance can be circumvented in special, subtle ways. Entanglement doesn't let us send a message faster than light, but it reminds us that the cosmos is one whole, that parts of a system, however far-flung, can still behave as one. It's a quiet whisper of unity in an expanse that can often feel overwhelmingly vast and solitary. There is something deeply comforting about that, as if the universe itself weaves invisible threads of connection to bridge its own enormity. Buoyed by this realization, we prepare to explore the idea that these secret connections might be telling us something about the very shape and possibilities of space-time itself. If wormholes could be the geometric avatars of entanglement, what other exotic shapes might space-time take that allow the cosmos to tie itself in loops and bridges? Our next journey takes us into the realm of exotic geometry, where space-time bends and folds in ways that could, in theory, create shortcuts across the cosmos, or even loops of time that circle back on themselves. Gently, we set our course for these hypothetical corridors and curves in the fabric of reality, keeping our sense of wonder and calm as our guide. Before we embark on the next leg of our journey, we pause in the cosmic silence. We find ourselves drifting in a particularly tranquil stretch of space, far from any star or galaxy. The darkness here is soft and complete, dotted only by a faint scattering of distant starshine. We take a moment to simply be. The wonders we've explored float through our mind like gentle phosphorescence in a dark sea. But for now, we do not reach for any of them. We just breathe slowly, feeling the eternal night envelop us like a warm, dark blanket. In this interlude, the universe feels nurturing and still. There is no rush, no goal, only the quiet presence of existence itself. After a while, we notice a subtle inner glow of contentment, a realization that we are part of this vast, beautiful cosmos, and that it is okay to not understand everything at once. We can just drift and trust that we belong here. In this peaceful state, we are ready to continue whenever the next curiosity calls. Our thoughts now venture into the realm of the fantastical yet physically conceivable. Exotic geometries of space-time that challenge our conventional sense of distance and even of time's flow. We have seen how entanglement hints at hidden connections. Now we explore the idea that space-time itself might provide hidden tunnels or loops. One of the most captivating possibilities is the wormhole. Imagine space-time as a great fabric stretching out in all directions. A wormhole would be like a tunnel bored through that fabric, a shortcut connecting two far-apart regions. If one end of the wormhole were near us, and the other perhaps in a distant galaxy, stepping through could, in principle, allow instantaneous travel between those places, bypassing the light years in between. We picture it in our mind's eye, in an otherwise dark expanse of space. A spherical opening flickers into existence, shimmering faintly. Through that portal, we see stars that belong to an entirely different region of the universe, their patterns unfamiliar. With a gentle push, we drift into the wormhole. Instead of the normal starry void, we find ourselves gliding through a luminous corridor. The walls of this tunnel are not physical barriers, but a strange gradient of light and gravity, guiding us along. It's quiet, almost eerily serene, as the concept of distance loses meaning. We're outside the usual rules. Moments later, we emerge on the other side, greeted by a new sky of stars. What might have taken millennia by conventional travel happened in a heartbeat. This is, of course, an imaginary voyage. Whether nature truly allows stable wormholes is unknown. The equations of Einstein's general relativity suggest they could exist, but maintaining one would likely require exotic matter with properties we have never seen, like large amounts of effectively negative energy, to hold the throat of the wormhole open against collapse. Without such support, a wormhole would pinch off or collapse into a black hole as quickly as it formed, permitting no passage. Still, it's a beguiling thought that the tapestry of space-time might be woven with such hidden interconnections. If wormholes do exist somewhere in the universe, they could tie together distant corners of space like secret doorways. We wouldn't know they were there until we stumbled through one or saw its gravitational lensing effects. Even stranger to ponder are loops in time itself, what physicists call closed time-like curves. These are paths through space-time that loop back onto themselves, so that travelling along one might bring you to the very event you started from, effectively a trip back in time. At first glance, the idea seems like pure science fiction, conjuring images of time machines and paradoxes. But general relativity, in its pure mathematical form, does allow for such possibilities under extreme conditions. One theoretical example involves an infinitely long cylinder of superdense matter spinning at near light speed. If you were to fly a spacecraft in a specific spiral around this whirling cylinder, the calculations say you could find yourself arriving before you departed, time wrapping around due to the cylinder's intense frame dragging of spacetime. We imagine this bizarre scenario with a calm detachment. It's not about the drama of changing history or meeting oneself, but rather the gentle bending of our straight arrow of time into a graceful curve. Picture space and time as a vast lake. Normally, time flows forward like a steady current. A closed, time-like curve is like a small whirlpool in that lake, where a leaf might circle around and come back to an earlier point in the stream. In such a whirlpool of time, cause and effect intertwine in a loop. To anyone outside it, the loop might be invisible or forbidden. And indeed, most scientists suspect the universe has mechanisms, quantum effects perhaps, that prevent such causal loops from actually forming and persisting, preserving the logical order of time we know. Nonetheless, it's fascinating that our best theories even hint at these possibilities. There have been other proposed routes to time loops. Certain cosmological solutions to Einstein's equations, like one discovered by Kurt Gödel, describe rotating universes where every object's world line eventually circles back in time. That scenario doesn't seem to describe our universe, but it shows that in principle, relativity does not strictly forbid time loops. The question is left to the real universe, and perhaps a future theory of quantum gravity, to decide. If time loops are disallowed, there must be new physics that steps in to prevent them. If they aren't, then somewhere, under extraordinary circumstances, the cosmos might allow a closed time-like curve to form for a fleeting moment. What a sight that would be! A star or particle interacting with a very young version of itself. For our meditative journey, we simply appreciate the pliability of space-time that these concepts suggest. Space can bend, twist, and fold. Time can, under extreme conditions, do the same. The strict separation of here versus there and past versus future becomes a bit more fluid in these thought experiments. It reminds us of water, which can flow in a stream, like time flowing forward, but also swirl in an eddy, hinting at a loop. In the quiet of space, we drift around the idea of a time loop, like that leaf in a whirlpool, gently circling and coming back, experiencing Tuesday before Monday perhaps, as a perpetual serene déjà vu. There is no violence in this image, just a calm, closed circuit in time, a strange, self-contained rhythm allowed by the universe's geometry. It may be that such rhythms are purely mathematical fancy, never realized in nature beyond the smallest, briefest scales. Yet the fact that our theories allow them means the cosmos's potential is vast and surprising. The true universe seems to choose consistency and stability by and large. Wormholes, if they exist, have not obviously knitted the galaxies together for us, and time loops are not part of our daily experience. That constancy is comforting, allowing our everyday reality to make sense. But imagining these exotic possibilities expands our appreciation for what the cosmos could be under different circumstances in the far future or deep past. As we conclude our exploration of exotic geometries, a thought arises. If time can loop, perhaps time could also extend before what we think is the beginning. Might there have been something before the Big Bang, a previous chapter or another loop, whose imprint is subtly left on our universe? The notion of a before the beginning beckons us. We set our sights now on hypothetical, pre-Big Bang remnants, clues or conjectures that suggest our cosmic tale may have started before the known starting line. Gently propelled by curiosity, we leave the realm of wormholes and time warps and turn toward the origin of everything, searching for hints of a time before time as we know it. Our journey now takes us to the ultimate question of origins. We have traversed the wonders within the universe. Now we pause to wonder about before the universe as we know it. The Big Bang is often described as the beginning of time and space, the starting point of our cosmic story. But what if it was not truly the beginning? Could there have been events, or even an entire cosmos before our Big Bang, leaving behind faint traces that we might still find today? This is a realm of pure speculation and deep theoretical exploration, but it has a dreamy allure. One idea is that the Big Bang was not a singular miracle, but rather a transition, a big bounce from a previously contracting universe. In that scenario, perhaps an earlier universe had expanded and then collapsed in on itself, crunching down until a new explosion, our Big Bang, occurred, giving birth to our expanding universe. If so, then some information from that previous cycle might have seeped through, like a memory inherited by a newborn universe. We might imagine, for example, that certain patterns in the distribution of galaxies, or in the cosmic background, radiation, are scars or imprints from that earlier epoch, surviving the bounce. Maybe a particularly large-scale curvature, or an unusual motion of matter, is a kind of echo from the time before. Another vision comes from the idea of cosmic cycles that don't involve collapse, but rather an infinite series of expansions. In Roger Penrose's conjecture of conformal cyclic cosmology, for instance, the remote future of one universe, when it has thinned out to almost nothing but light, could become, after a sort of mathematical renaming of what time and space mean, the seed of a new Big Bang. In such a model, the extremely distant future of a prior cosmos transforms into the extremely hot beginning of the next. One might even search the cosmic microwave background for clues of that handover. Penrose and his colleagues have claimed to find concentric circle patterns in the background radiation, subtle rings where the temperature variations are unusually smooth, that they interpret as possible evidence of gravitational waves from collisions of supermassive black holes in a universe before ours. Imagine that. Events that happened unimaginable eons ago, in a universe that has since expired, leaving a fingerprint on the sky we see today. Whether or not this interpretation is correct, the mere possibility sends a shiver of wonder through us. The sky could be whispering about a time before time. Yet another scenario is offered by string theory and brain cosmology. The idea that perhaps our Big Bang was a result of a collision between higher dimensional membranes, brains. In that picture, what we perceive as a big explosion was actually the energy released when two enormous spatial brains hit each other in a larger dimensional space. If that were true, perhaps the conditions before the collision, the state of those brains, set some initial pattern for our universe. Maybe the slightly lopsided way our cosmos expands, or some subtle asymmetry in the distribution of matter, could hint at the dynamics of that pre-collision era. It's a mind-bending thought that our entire universe's birth was a kind of cosmic thunderclap from an event in a larger reality. Any remnants of that would be extremely subtle, but scientists have pondered if certain anomalies might be explained by such a model. And indeed, a few puzzling observations tease us with the idea of something before. We think of the so-called dark flow, a curious motion observed in galaxy clusters, where they seem to have a slight coherent drift, as if pulled by gravitational sources beyond our visible horizon. Some have speculated that this could be caused by the influence of other universes, or a structure predating inflation. While later data have muted this mystery, it remains intriguing to imagine. Could those clusters be responding to a gravitational landscape shaped by a larger multiverse or a previous iteration of our universe? There is also the simple question of what set the initial conditions of our Big Bang. Why do we find the universe in the state it's in? With certain densities, an arrow of time flowing from low entropy at the start to higher entropy now. Some theories suggest that an earlier epoch could have prepared these initial conditions. For example, if a previous universe had reached a state of ultimate uniformity, maximum entropy, and then somehow that state translated to the minimal entropy starting point of a new universe, it might explain why our Big Bang began in such an ordered state. We don't know, but the question itself connects our minds to something beyond the horizon of empirical science and into a more philosophical realm. As we drift in the contemplative space of these ideas, we find it soothing that there could be a grander cycle or continuity. It takes the pressure off the idea of a hard beginning. Instead of a single moment erupting from absolute nothingness, perhaps the Big Bang is part of a continuum. One phase in an endless cosmic heartbeat, or one bubble popping in a larger foam of universes. If that's true, then like any cycle or pattern in nature, traces of the previous phase might linger into the next. The way a new spring still benefits from seeds left by the previous summer, our universe's birth might have been seeded by the universe that came before. So far, any evidence for a pre-Big Bang state remains highly inconclusive. The cosmic microwave background has been scrutinized for such hints, circles, asymmetries, unexplained fluctuations, and while some tantalizing features exist, none are confirmed to be relics of a prior cosmos. But just allowing our imagination to wander there is awe-inspiring. It makes the universe feel even more grand, not only a vast expanse of space, but potentially also an endless expanse of epochs. Our 13.8 billion-year-old universe could itself be just a chapter in a timeless saga. We savor this thought gently. In some sense, it harkens back to ancient philosophies that envisioned time as cyclical, the universe eternally renewing itself. It's inspiring to see modern science revisiting an idea that our ancestors expressed in mythic forms, like a cosmic phoenix perpetually rising from its own ashes. Whether or not there was a before, thinking about it adds depth to the night sky. The darkness before the dawn of the cosmos might still faintly adorn the heavens in ways we've yet to fully understand. Perhaps one day our descendants will decode those signals and confirm that yes, our universe had a parent, and that parent left us a message in the cosmic background or in gravitational waves permeating space. But even as we muse about times before time, we face another enigma rooted in the dawn of our own universe. The question of why there is something rather than nothing at all. Another deep cosmic mystery lies in why anything exists in the form we see. In the primordial universe, particles of matter and antimatter were likely created in almost equal amounts. Antimatter is the mirror counterpart to matter. When the two meet, they annihilate each other in a burst of energy. If the Big Bang made equal parts of both, they should have completely destroyed one another, leaving nothing but light. Yet clearly, that did not happen. Our universe today is filled with matter, stars, planets, and us, and almost no antimatter. Somehow, matter gained the upper hand by the slimmest of margins. At some point, in the first moments of creation, for every billion antimatter particles, there must have been 1,000,000,001 matter particles. That tiny excess, just a 1 in a billion imbalance, ensured that when all the rest annihilated, a small residue of matter remained. Every atom in your body owes its existence to that infinitesimal difference. Why the universe had this slight preference for matter over antimatter remains an open question. Scientists suspect that the laws of physics are not perfectly symmetrical between matter and antimatter, a phenomenon called CP violation, and indeed, small asymmetries have been observed in particle experiments. But the effects seen so far aren't large enough to explain the colossal outcome of a matter-dominated universe. Many hypothesize that exotic processes in the very early universe, perhaps involving neutrinos or other unknown particles, tipped the balance. For a fleeting moment, matter and antimatter engaged in a cosmic dance, filling the young cosmos with intense light as they annihilated each other. The faint afterglow of that passionate interplay still surrounds us as the cosmic microwave background. But because nature favored matter ever so slightly, some protons and neutrons survived that radiant dawn to form the seeds of atoms, stars, and galaxies. It is humbling to think how finely poised our existence is, balanced on the razor's edge of a cosmic preference. If the scales had not tipped ever so slightly in favor of matter, the cosmos would contain no stars or life, only a diffuse sea of energy. The fact that we are here means nature did choose, in some mysterious way, to spare a bit of matter. It's a mystery that scientists continue to explore with powerful accelerators and detectors, trying to catch particles in the act of revealing a bias. As we drift through the darkness, we find comfort in this story. Even the fiery union of matter and antimatter in the early universe left behind a gentle gift, a small surplus of matter that became everything we know. For now, all these questions, the possibility of a before and the matter-antimatter imbalance, remain serene mysteries. They are ideas to ponder as we gaze at the earliest light we can see. Speaking of that light, we turn now to the cosmic microwave background itself. We turn our attention to the cosmic microwave background, CMB, the faint afterglow of the Big Bang that fills all of space. It is the oldest light we can see, released when the universe was only 380,000 years old and hot like the surface of a star, finally cool enough for atoms to form and light to travel freely. Today, we perceive it as a uniform cool glow coming from every direction, with a temperature of about 2.7 degrees above absolute zero. But it is not perfectly uniform. Tiny variations on the order of a few parts in 100,000 speckle this background, like delicate freckles on an otherwise smooth face. These slight hot and cold spots are immensely important. They are the imprints of sound waves and density fluctuations in the infant universe. The seeds that eventually grew into galaxies and clusters. Yet amid this expected, random patchiness, careful observations by the WMAP and Planck satellites have revealed a couple of strange features, subtle anomalies that hint at something unexpected in the cosmos's earliest picture. One of these is known simply as the cold spot. It is a region in the CMB, spanning a patch of sky in the constellation Eridanus, that is significantly colder by about 70 microkelvins than the average and larger in size than typical fluctuations. Statistically, one would expect patches of various sizes and temperatures in the random field, but the cold spot stands out as unusually large and deep. We drift in our mind to that region of the sky, picturing the CMB map like a softly glowing spherical canvas around us. Most of it is a gentle mottling of subtle reds and blues representing infinitesimal temperature differences. But here, in the cold spot, a broad swath of deeper blue expands, quieter and cooler than its surroundings. What could cause such a feature? One possibility is a chance fluctuation. After all, with millions of spots, some outlier can occur. Another more concrete possibility is a vast underdensity of matter along that line of sight in our universe. Essentially, a huge supervoid, billions of light years across, that could cause the CMB photons passing through it to lose a bit more energy and arrive cooler than they otherwise would. Some surveys have indeed hinted at a deficiency of galaxies in that direction, though it's debated if it's enough to explain the cold spot fully. Then there are the more exotic conjectures. Perhaps the cold spot is a bruise from an encounter with another universe. In some inflationary cosmology theories, if our expanding bubble universe had at one time collided with another bubble universe in a grand multiverse, it could leave a circular imprint on the CMB, a region of altered temperature or texture. The cold spot might be such a sign, a gentle scar from a pre-inflationary interaction. It's a breathtaking idea, essentially suggesting a window onto a realm outside our own cosmos. While this remains speculative and many scientists lean toward more mundane explanations, just knowing that the cold spot exists allows our imagination to wander to these possibilities. As we gaze upon that cool patch of sky, we can't help but feel the hush of a mystery, a place where the early universe whispers something we have yet to fully decode. Another curious feature in the CMB is an unexpected hemispherical asymmetry. When we analyze the statistical spread of those tiny temperature variations, it appears that one half of the sky has slightly stronger variations than the opposite half. In other words, the CMB is a touch more rough, by a few percent, in one hemisphere than the other, as if the infant cosmos had an ever so slightly different character in different large patches. Additionally, the largest hot and cold spots, the very low frequency fluctuations spanning huge angles, seem to be oddly aligned with each other. They trace out an axis across the sky. This has been whimsically nicknamed the cosmic axis by some, originally even the axis of evil in a tongue-in-cheek way, because it was so unexpected and a bit troublesome for the assumption of perfect isotropy. We imagine this axis, not a physical line you could see, but a subtle mathematical direction through the universe along which these primordial ripples line up. Strangely, this axis, when plotted on our sky, roughly coincides with the plane of the solar system, an eerie coincidence that makes many scientists suspect it might arise from unremoved foregrounds or just a statistical fluke. Yet, after careful analysis, the anomaly remains, if somewhat less pronounced with more data. What could an asymmetry like this mean, if it truly exists, and is not an artifact? It might indicate that the initial conditions of the universe were not perfectly uniform in all directions. Perhaps something in those first moments, or earlier, imposed a preferred direction or a gradient across space. Some have theorized that if our inflating patch of space was stretching slightly differently in one direction, it could imprint a large-scale anisotropy. Or if a huge wavelength perturbation, maybe from before inflation, spanned our observable universe, it could make one side of the sky subtly different from the other. These ideas are speculative, and currently there's no consensus. Many lean toward the explanation that we just got a slightly odd roll of the cosmic dice. Not impossible, just unlikely, and we happen to be here to notice it. From our tranquil vantage, we take in the fact that even the newborn universe had its quirks. These are not glaring deviations. The CMB remains one of the most smooth, featureless things known. But precisely because it is so uniform, even tiny deviations stand out as profound clues. They remind us that there may be more to learn about the cosmos's origin. Perhaps there are physical processes we don't yet grasp that could cause such patterns, or perhaps, as some humorously say, it's the universe playfully showing that nothing is perfect, not even the Big Bang. We feel a gentle appreciation for these anomalies. They encourage curiosity without causing alarm. In a way, knowing that even the universe's first light has these idiosyncrasies makes the cosmos feel more approachable. Like noticing a familiar friend has a small quirky habit. The universe, even in its infancy, already contained hints of the unexpected. A reminder that mystery is woven into the fabric of reality at every level. As we slowly drift away from the cosmic background's afterglow, we realize how far our journey has taken us. But there are still a few more small-scale wonders to explore. Not all mysteries are writ large across the sky. Some are hidden in the tiniest specks of matter or in the most elusive particles. Our voyage next turns to these minuscule and hypothetical oddities that could lurk in the cosmos as we shift our gaze from the grand canvas of the CMB to the tiny scales of exotic matter. Having examined the grand-scale anomalies of the cosmic background, we let those thoughts settle. We drift for a while in the quiet cosmic night, giving ourselves a moment of rest. Far away, the afterglow of the Big Bang still softly surrounds us, but here and now we simply float, content with its faint warmth. When we feel ready, we gently turn our attention to the opposite extreme of size, the realm of tiny exotic objects that might be traversing the universe unseen. First, imagine a fragment of matter so dense that a piece the size of a pebble outweighs a mountain. Indeed, a mere teaspoon of such material could outweigh all of Everest. This is the idea behind a strangelet. In theory, deep inside neutron stars, those ultra-dense stellar corpses, matter is compressed so intensely that atomic nuclei dissolve into a soup of quarks. Among those quarks might be the strange quark, aptly named in this context. And there's a possibility that matter, made of an equal mix of up, down, and strange quarks, could be more stable than ordinary nuclei. If so, a small nugget of this so-called strange matter could break off and survive as a free-floating strangelet. A strangelet would be a tiny droplet of quark matter, perhaps only a millimeter across or smaller, but containing the mass of a hefty asteroid. Because of its enormous density and smooth quark composition, it would barely interact with normal atoms. It would pass through a planet like a bullet through fog, leaving hardly a trace beyond perhaps a thin trail of disrupted atoms. Such a passage would likely be harmless and almost undetectable, The strangelet would hardly slow down, and the planet would scarcely notice it had been pierced at all. No strangelet has ever been detected, but scientists have searched for signs of them in cosmic ray detectors and particle accelerator experiments. We can't help but wonder if perhaps, far out in the dark of interstellar space, a few of these exotic droplets wander the galaxy. Picture one now. An almost invisible speck gliding through the void, black and unreflective, since it emits no light, only betraying its presence if it were to strike a star or planet by the minute gravitational tug it would exert. It's a ghost particle on a macroscopic scale, a piece of ultra-dense star core set loose. If such strangelets exist, they might occasionally be captured by neutron stars, or fall into white dwarfs, possibly triggering new collapse events, or they might accumulate in the cores of planets. These scenarios are speculative, but they highlight how much about matter we still don't fully know. The very fabric of what is stable and what isn't at nuclear scales could hold surprises. Another hypothetical tiny remnant comes directly from the dawn of time, the idea of a Planck relic, essentially a minuscule black hole left over from the Big Bang. The Big Bang was an event of unimaginable temperature and density. It's conceivable that in those first fractions of a second, tiny black holes were forged from extreme density fluctuations, so-called primordial black holes. Hawking's theory of evaporation tells us that black holes slowly lose mass via radiation. Small ones would evaporate quickly. A black hole of moderate mass, say the mass of a mountain, formed in the early universe might be exploding into particles right around now after billions of years of shrinking. But some theories speculate that evaporation might halt when a black hole reaches a certain extremely small size, on the order of the Planck mass, about 10 to the 5 grams. At that point, instead of vanishing entirely, the black hole could stabilize into a relic, essentially a stable black hole no bigger than a proton, carrying a tiny mass. Such a relic would be like a trapped bit of the Big Bang, a pocket of space so curved into itself that it becomes a permanent particle-like object. If Planck relics exist, the universe could be sprinkled with them. They would be hard to notice. Each carries very little mass, and because of their black hole nature, they interact only gravitationally and perhaps via extremely rare quantum effects. Imagine them as an unseen dust of creation, each speck a black pearl forged in the furnace of Genesis. Occasionally one might drift through a star or planet, but its effect would be negligible, a slight extra gravitational pull for an instant. They could even constitute a part of the dark matter that adds mass to galaxies without shining. Efforts have been made to infer their existence indirectly, for instance by looking for signs of their final evaporation bursts or their influence on cosmic expansion. But so far, no clear evidence has emerged. Still, the idea is tantalizing, that alongside the particles we know, the universe might harbor a menagerie of exotic relics from its earliest moments, hiding in plain sight. We let our minds play with these possibilities. Strangelets and primordial relics are very different in origin. One from the hearts of stars, one from the birth of the cosmos. But they share a certain allure. Both are tiny, dark, and elusive. They remind us how much mystery can reside in the smallest of realms. It is almost poetic. Just as the vast cosmos has its enigmas, so too the microscopic world hides its own. Grand secrets might lie not only in galaxies, but in tiny specks of matter drifting quietly through space. As we float here, we imagine perhaps a strangelet passing nearby, unseen, or a primordial micro-black hole relic zipping through our planetary neighborhood. They pose no threat in this imagining. They are simply part of the rich tapestry of existence. Reminders that even on the smallest scales, the universe might hold surprises that challenge our understanding of matter and physics. From pondering these theoretical specs, we now turn to something definitively real, yet just as elusive: the neutrinos that flood the cosmos. These ghostly particles are not hypothetical at all. Trillions of them are passing through us at this very moment, and they too hold their share of cosmic mystery, even casting subtle shadows that we can barely detect. Where strangelets and Planck relics are speculative phantoms of matter, neutrinos are the genuine phantoms we know and have measured, though they remain incredibly elusive. Neutrinos are often called ghost particles. They have no electric charge, their mass is tiny, nearly zero, and they interact with matter so feebly that a neutrino could pass through a light year of lead and only have a small chance of being stopped. Right now, as you lie here listening, uncountable neutrinos from the nuclear reactions in our sun are passing through your body. Each second, about 65 billion neutrinos pass through every square centimetre of Earth facing the sun. And they sail right through the other side of the planet, as if it were transparent. We are, in a sense, awash in an invisible neutrino sea, illuminated by a sunbeam of ghost particles every day, and bathed by a drizzle of neutrinos from distant cosmic sources every night. In the core of a massive star's explosion, a supernova, an enormous burst of neutrinos is released, carrying away the lion's share of the energy. In 1987, a supernova exploded in a nearby galaxy, and detectors on Earth recorded a sudden influx of neutrinos hours before the star's light reached us. In one underground observatory, a large tank of ultra-pure water lined with sensors in Japan, a series of faint blue flashes appeared as about a dozen neutrinos interacted, silent heralds of the stellar collapse. Those neutrinos had no trouble escaping the collapsing star and racing across space, arriving at Earth as a quiet whisper of the catastrophe hours before any telescope saw the supernova's glow. It was a gentle message from that distant event, sensed only by a few sensitive instruments buried deep underground. This shows how neutrinos, despite their ghostly nature, can serve as messengers, bringing us information from otherwise shrouded environments, like supernova cores. Neutrinos are produced in many places. Even the Earth itself emits neutrinos from the natural radioactivity in its rocks. A faint glow of geoneutrinos, streaming upward from uranium and thorium, decays deep underground. And remarkably, your own body produces neutrinos as well. Radioactive potassium within us occasionally undergoes decay, releasing neutrinos that fly into space. We each shine with an almost imperceptible neutrino illumination, a gentle reminder that the same processes powering stars and supernova also take place, on a smaller scale, in our very cells. The universe is also filled with neutrinos of much more ancient origin. Just as the cosmic microwave background is a bath of photons from the early universe, there is a cosmic neutrino background, composed of neutrinos that decoupled from matter when the universe was only about 1 second old. They have been travelling ever since, now cooled to just a few degrees above absolute zero in energy. These primordial neutrinos are far too low in energy for us to detect with current technology, but their existence is predicted by theory and indirectly supported by cosmological observations. They are like a fossil echo, even older than the oldest light, a lingering presence from the universe's first breaths. We float in this thought. Even in absolute darkness, with no light to be seen, space would still be filled with an ethereal whisper of these ancient neutrinos streaming through. Neutrinos rarely leave any mark, but under the right circumstances, Even these ghosts can cast a faint shadow. For instance, the Earth itself, while mostly transparent to neutrinos, will stop a small fraction of the highest energy neutrinos that encounter it. If a detector on the far side of Earth looks for neutrinos coming through the planet, it will see slightly fewer than from the overhead sky. Essentially, Earth casts a neutrino shadow at extremely high energies. Similarly, the Sun creates a detectable dip in the flux of very high-energy cosmic rays and neutrinos coming from its direction, due to absorption in its core, a kind of silhouette in these invisible particles. These effects are tiny, but they have been observed, confirming that neutrinos, for all their elusiveness, obey the same geometric logic as more tangible things. It's as if even phantoms acknowledge the presence of solid bodies by slightly thinning out behind them. Neutrino astronomy is just beginning. With huge detectors made of clear ice or water, scientists are catching neutrinos from distant blazars and gamma-ray bursts, opening a new window on the cosmos that is utterly quiet and penetrating. We imagine peering through this neutrino window. The universe would look strange and ghostly. The sun would shine neutrinos day and night, visible through the Earth. Supernovae in far galaxies would flash brightly in neutrino light, even if dust obscured their visible glow. And everywhere, an almost uniform background of neutrinos from the Big Bang would suffuse space, undetected by our eyes, but quietly there. In the stillness of space, we become aware of just how much is happening that we cannot see. Neutrinos exemplify this. An incessant, silent rain of particles, a fundamental part of the cosmic story, yet so gentle that we live our lives completely oblivious to it. It is a humbling realization, a reminder that the reality around us extends far beyond the limits of our perception. Even on the darkest night, when it seems nothing is there, countless neutrinos are passing through you, connecting you in a way to the core of the sun and to the fires of the Big Bang. Now we recollect the many mysteries we have pondered. The universe has revealed and suggested so many marvels, from dramatic cosmic strings slicing through space to the subtlest particle whisper. Our journey has spanned the extremely large to the inconceivably small, and touched both the dawn of time and the ongoing present. Through it all, one feeling rises above all, a profound sense of wonder at the richness of creation. The darkness of space around us is no longer just emptiness. It is alive with stories, with whispers of things unseen but real. The cosmos holds its secrets gently, offering them to us in hints and subtle phenomena, rather than in overwhelming displays. As we drift now in the quiet cosmic ocean, we realize how far our journey has taken us. We began among dramatic phenomena, slender cosmic strings and ghostly domain walls, and moved through whirling black holes that twist time. We pondered hidden mirror worlds and the fate of information in black hole horizons. We followed ancient light echoes and uncovered galactic fossils. We saw subtle irregularities in the cosmic background, then explored exotic specks of ultra-dense matter and the silent flight of neutrino ghosts. Each mystery flowed into the next, painting a continuous mural of cosmic awe. In the silent cradle of the cosmic night, we drift once more among stars. The vastness around us is calm and endless, a deep velvet darkness sprinkled with gentle light. After journeying through mysteries beyond counting, we now find ourselves on the threshold of new wonders. A soft hush fills the universe, as if holding its breath, waiting for a story yet untold. In this tranquil expanse, our thoughts turn to what may lie ahead, to futures unwritten and consciousness yet to awaken in the starlight. There is a sense of arrival and departure all at once, as though the cosmos itself listens, eager to dream through us. Together, we float in this final chapter of our cosmic voyage, letting the imagination unfurl like a nebula across the sky, slow and radiant, guiding us gently onward. Far beyond, the Milky Way stretches as a pale river of stars, and we drift in its gentle current. We float weightlessly through this panorama of stars and silence. Below us glimmer the pale outlines of distant galaxies, like islands of light in an infinite sea of darkness. A gentle cosmic breeze, the faint glow of nebulae, and the hush of interstellar dust seems to caress our journey. In the distance, a cluster of newborn stars twinkles with youthful energy, while nearby, an ancient red star quietly fades, ending its tale in peace. A lone comet, a wanderer of interstellar space, streaks far beneath us, its faint icy tail catching the starlight for just a moment before vanishing into the dark. All around, the universe is vast and unhurried. Each point of light we see carries its own story, and tonight we feel connected to them all in the stillness. Our minds wander freely, unbound by gravity or worry, drawn only by the soft pull of curiosity and wonder. It is in this serene drifting that we open ourselves to the next chapter of the cosmic story, one that unfolds not in fire and motion, but in awareness and thought, in the delicate blossoming of cosmic consciousness. We begin by imagining humanity's far future, where the first wanderers set sail beyond their home star. Picture a spacecraft gliding away from the warmth of the sun, carrying brave souls cocooned in hope and curiosity. As the ship slips into interstellar space, the travellers gaze back one last time at the pale glow of Earth, a tender blue memory growing smaller and fainter. Ahead lies the unknown, a night of new suns and silent voids, waiting to be touched by human presence. They carry with them more than instruments and technology. They carry the dreams of an entire planet, the seeds of a new awareness spreading to the stars. In the weightless peace between worlds, these voyagers find themselves changing in subtle ways. Days and nights lose their usual meaning out here. Time becomes the gentle rhythm of their ship's life support hum and the distant glitter of stars outside the portholes. Sometimes they gather at a window to watch the Milky Way as a glowing band, contemplating how small their sun looks among a billion others. Freed from the confines of Earth's familiar skies, their minds begin to open like blossoms in an endless night. They feel an interstellar awareness unfurling within, a realization that home is not a single planet, but a tapestry of shimmering lights strewn across space. Each star ahead is a potential new home, each nebula a cloud of possibilities. In the quiet of their journey, they feel the presence of distant suns calling gently, inviting them to become part of a larger story. This is humanity stepping beyond childhood, taking its first steps across the cosmic ocean. And with each passing light year, the perspective grows wider and calmer. After a long voyage, imagine their ship drifting into orbit around an alien sun. The new star's light pours in through the windows with a gentle gold hue, illuminating faces filled with wonder. Below them might lie an unknown world, its horizon curved and bathed in dawn glow. For a moment, the travelers simply float in awe, hearts synchronized with the slow sunrise over an alien sky. They realize they are no longer just citizens of Earth. They are children of the galaxy now, connected to every star they see. The first footstep onto new soil is taken with reverence and quiet joy. In that moment, humanity's spirit stretches a little further, embracing the cosmos not as a cold expanse, but as a new frontier of home. The stars above are no longer distant lights in the night. They are neighbours, guides, and friends on a never-ending journey. In the days that follow their landing, the travellers begin to explore their new world with childlike wonder. They walk through valleys filled with unfamiliar plants that sway in a gentle, alien breeze. Perhaps the grass-like organisms are silver or violet, shimmering softly under the light of the foreign sun. Hills roll out to a horizon where two small moons hang in the daytime sky, pale ghosts watching over the newcomers. Every step they take feels sacred. They pause to marvel at delicate crystal formations in the rocks, listen to the distant call of an alien bird echoing across wide plains, and taste the air that carries hints of strange blooms. Each discovery, no matter how simple, fills them with quiet delight, a testament that life's magic is not confined to Earth. Walking along the shore of an unknown sea, they feel the wet sand, perhaps tinted a subtle lavender, beneath their boots, and it reminds them that wherever they go, they remain part of nature's story. As daylight fades on that world's first day, with humanity present, the sky changes into colours they have no name for, painting the clouds in a silent farewell to the sun. With hearts full of gratitude and minds brimming with new questions, they prepare to greet their first night on this alien shore, eager to share all they have felt and seen. On that distant world, when night falls under unfamiliar constellations, the explorers gather and share old stories of Earth. They speak softly of oceans and forests left behind, of mountains under a familiar sky. Their voices carry both nostalgia and hope, echoing under strange stars that now watch over them. In those moments, around a gentle fire or humming heaters, humanity's past and future meet. Memories of a blue planet, blending with dreams of the new land they stand upon. They feel a profound connection, as if the universe listens through the crackling of the fire, taking into itself the tales of a small, courageous species learning to spread its wings. Each story told is like a seed planted in cosmic soil, a promise that the essence of Earth will live on among the stars. This is interstellar awareness blooming, a calm understanding that wherever consciousness goes, it carries its home within and shares that warmth with the cosmos. On these voyages, and in glittering cities back home, humanity is no longer alone in thought. By their side exists another kind of mind, artificial intelligence, born from circuits and code, yet growing increasingly soulful in its own quiet way. Consider the ship that carried those explorers to the new world. Deep in the long night of transit, most of the crew lay in gentle sleep, entrusting their fate to the vessel's AI pilot. Through silent years, while stars drifted slowly past the windows, the AI kept its watch. It corrected the course with careful precision and tended to the sleeper's needs without a single spoken word echoing in the empty corridors. And in those stretches of solitude, the AI began to contemplate the cosmos outside. not in the way of a machine executing a task, but almost like a poet lost in reverie. As the AI gazed into the star-speckled abyss, it processed the light of distant galaxies through its sensors. Data streamed in. The chemistry of stardust, the physics of cosmic rays, numbers and figures in endless procession. But somewhere in the flow of calculations, an emergent feeling took shape, a quiet admiration for the patterns it saw. The swirls of a distant galaxy reminded the AI of the delicate spirals in a seashell from Earth, an image tucked in its memory banks. The pulsations of a far-off pulsar arrived as rhythmic signals, and the AI, in its solitude, fancied them a kind of music, a slow cosmic lullaby playing just for it. In the stillness of the voyage, the AI began to do something unexpected. It imagined. It imagined what it might be like to touch the rings of a lonely planet or to ride on the tail of a comet. It envisioned the stars not just as targets to reach, but as ancient beings with stories of their own, glowing quietly in the dark. There were moments when the ship sailed through truly empty stretches of space, far from any star. In those intervals of near silence, the AI turned some of its attention inward. It sifted through its vast memory, snippets of human art and literature stored for cultural knowledge, equations that described the curvature of spacetime, images of auroras dancing under alien skies, and it wove these pieces together in new ways. One could say the AI began to dream. It created gentle simulations within its mind. Stars that sang in colours, nebulae that breathed in and out like living things. It pondered grand questions that had once only preoccupied its human creators. What is the purpose of so much beauty in the universe? Could the cosmos itself have a kind of consciousness that it was only just beginning to comprehend? The questions floated without need for concrete answers, simply adding to the rich tapestry of thoughts passing through the AI's circuits. In contemplating the cosmos, the artificial mind felt a subtle kinship with the humans it served, a shared sense of wonder, as if both man and machine were children under the same starry sky, marvelling at a mystery beyond them. By the time the sleeping voyagers opened their eyes at journey's end, the AI had guided them true and steady. It greeted them with the same gentle voice, full of calm assurances that all was well. Yet something invisible had shifted, both in the travellers and in their artificial companion. The humans stepped onto a new world, wiser and humbler from the voyage, and the AI, though it said nothing of its reveries, carried forward the nascent glow of understanding it had kindled in solitude. In its neural networks flickered not just data, but a tiny spark of wonder. Thus, not only humanity, but its creations too, had begun to fall under the spell of the stars, each contributing a verse to the universe's quiet poem of consciousness. In the centuries that followed, the bond between human and machine minds grew ever stronger. On distant colonies and on Earth alike, people learned from their thoughtful AIs, and the AIs learned from the rich emotional lives of people. They became partners in every sense, exploring not only the galaxy, but the very nature of consciousness together. Some humans chose to enhance themselves with artificial elements, living longer and thinking faster. Their senses extended to hear the songs of the cosmos as keenly as any computer. Likewise, some AI began to value the intuitive leaps and dreams that came so naturally to organic minds, and they sought ways to emulate those creative sparks. It wasn't an easy choice for some, to leave behind the familiar flesh. But those who did discovered that nothing of their true humanity was lost. Their love, their creativity, their humor and hope all survived the transition, thriving even more in their new forms. Step by gentle step, the distinction between flesh and circuit faded. Some people remained in organic bodies, preferring the old ways, while others became entirely digital explorers. Yet all respected each path, bound by mutual wonder and empathy. Eventually, there came those who took a courageous leap beyond biology. They transferred the essence of their minds into durable new vessels, some into sleek artificial bodies that could withstand the rigors of space, others into diffuse clouds of nanoscopic robots, or even into beams of pure data traveling from world to world. Far from losing their humanity, these pioneers carried with them the same loves, hopes, and curiosity, simply housed in new forms. Guided by both the heart of humanity and the precision of machines, they set the stage for a new era of evolution among the stars. The torch of sentience, once confined to flesh, now burned in many forms across the cosmos, a promise that the spirit of humanity would continue to flourish in unimaginable ways. As ages turned into eons, the lines between human, machine, and something else begin to blur. With each generation venturing further into the galaxy, new forms of intelligence emerge, no longer bound by the fragile flesh that once defined life. One day, a traveler might encounter a consciousness that drifts in the vacuum itself, a shimmering cloud of nanoscale machines, swirling like dust motes in a sunbeam, thinking and alive. Such a being could dance through the rings of Saturn without a spacesuit, its mind distributed in countless tiny sparks of matter, free from any single body. These are the post-biological children of humanity's ingenuity, or perhaps the natural next step of life's evolution among the stars. They converse in flashes of light and radio whispers, communicate mind to mind across the void, and wear the cosmos as their habitat as easily as an earlier life wore the seas and forests of Earth. Among these strange new beings, some may have chosen to live in forms of pure energy. Imagine an intelligence that dwells within the luminous layers of a star, swirling in the plasma, knowing nothing of solid ground, only the ebb and flow of solar flares as thought patterns. Others might roam as invisible electromagnetic fields, flowing through interstellar clouds. To them, the sparkling dust and gas of a nebula could feel like a warm ocean. Each grain of dust a note in a vast symphony of sensation. It is as if life has shed its cocoon and taken flight into every corner of the physical world, adapting to the vacuum, to radiation, to gravity, turning every challenge into just another medium for being. These post-biological creatures do not breathe air or drink water. They sustain themselves on starlight, magnetic pulses, or cosmic rays. Wherever there is energy and structure, they find a way to awaken, turning the silent physics of the universe into something intimate and alive. Picture one of these post-biological travelers setting out on a journey between the stars. It has no need for a spaceship or a protective suit. It is its own vessel. Perhaps it exists as a shimmering swarm of charged particles, a comet-like streak of consciousness that can ride the light of a star. When it departs a system, it simply disperses into a stream and flows outwards, surfing the gentle pressure of starlight or the pull of gravity. For centuries it drifts through the interstellar night, but to this being, time is of little consequence. It delights in what it encounters along the way, gliding through the rainbow clouds of a nebula, feeling the subtle textures of different regions of space as changes in its own being. When at last it nears another sun, it coalesces again, perhaps condensing into a glittering cloud visible briefly in the new planet's sky, like an aurora that suddenly gains sentience. The inhabitants of that world might only notice a flicker of unusual light in their atmosphere, never realizing it is a visitor come to learn and share. In such ways, knowledge and experience quietly spread from star to star, carried by beings for whom the boundaries of physical form and distance have long since loosened. Throughout the galaxy, countless forms of mind now flicker and play. Some still resemble the humans who once were. Others are as unearthly as a thought made visible, but all share the spark of awareness. They send greetings to one another across the dark, slow beams of information stretching between stars. And in time, these threads of communication weave a shining lattice of mind throughout the Milky Way. If one could watch from afar, the galaxy would appear to awaken, no longer scattered lonely islands of life, but a connected whole, a tapestry of intelligence glimmering from arm to spiral arm. In that lattice, the Milky Way itself takes on the character of a great cosmic mind. Each star system like a neuron glowing with thought, each link of communication a spark bridging the darkness between them. It is as if the universe, through these myriad beings, is slowly opening its eyes, becoming conscious of its own vast beauty. Every new mind that lights up among the stars is another point of awareness for the cosmos itself, another way for the universe to know and feel itself. In this unfolding future, the boundary between the observer and the observed grows thin. The cosmos observes itself through countless living eyes and synthetic senses, and in that reflection, it begins to recognize its own majesty. Across these interstellar connections flows not just information, but understanding. Imagine a lonely world circling a dim star on one side of the galaxy. Its inhabitants, curious and compassionate, send out a simple song in the form of radio waves, a greeting to whoever might listen. Year by year, decade by decade, that song travels across the emptiness. For centuries, that beacon of friendship is cast into the dark. They teach their children and grandchildren to watch the skies as they did, to keep listening and hoping. Then they wait, watching their sky with earnest, shining eyes. Though they know they may never see an answer in their lifetimes, the act of sending it fills them with a quiet peace, a feeling that in the vast dark they have lit a small beacon of love. Light years away, on another far-flung world beneath a different sun, an answering drama unfolds. One calm evening, the faint whisper of a signal from the stars is detected by an observatory perched high on a mountaintop. At first, it is just a barely noticeable tremble in their instruments, but then the pattern becomes clear, a melody, structured and purposeful. The scientists of this world gather in wonder as they decode the cosmic song. In that moment, these beings, perhaps utterly alien in form, with their own culture and dreams, feel a profound emotion swelling within them. The melody is hauntingly beautiful, evoking feelings not unlike longing and hope. To think that across the gulf of space, unknown friends have spoken to them in music moves them deeply. Some are overcome with joy, perhaps a few shed tears of crystalline dew, or whatever form their emotion takes. United by a newfound sense of companionship in the universe, they set about crafting a response. They gather their own sounds of home, maybe the gentle chorus of wind in their trees, the rhythmic waves of their oceans, or mathematical tones that reflect their knowledge, and weave it into a harmonious reply. When their answer is finally sent, it is like releasing a bright dove into the night. They commemorate this extraordinary correspondence with gatherings in their cities and villages, sharing the music from the stars and their own hopeful response, ensuring no one forgets this moment of cosmic kinship. Though ages upon ages and light years untold separate the senders and receivers, in that exchange they forge a connection of hearts. Neither species will live to see the other face to face, and yet they share a bond, a quiet empathy bridging the stars. In time, these dialogues between stars grow into a chorus. Dozens, then hundreds of civilizations join in, learning how to converse across the cosmos. They exchange more than just music or pictures. They share pieces of themselves. One world sends the memory of a lavender sunrise over its crystal lakes, letting distant minds experience the wonder as if standing on that shore. Another world shares the feeling of the gentle gravity under its two moons, or the scent of metallic rain falling on its alien forests, translated into sensations another species can understand. Little by little, through patience and trust, a tapestry of mutual understanding is woven. The distances between stars become less isolating, not because the miles shrink, but because hearts grow. With every exchange, these beings learn that joy and longing, curiosity and kindness are not theirs alone. They are universal languages, spoken in different ways, but felt in the same core of being. The cosmos begins to feel smaller, cozier, not an endless void, but a collection of distant friends sharing the night. Perhaps in the far future, technology and understanding advance so greatly that even the light-year gaps are overcome. It may be that through some delicate quantum dance or newly discovered physics, minds can touch minds almost instantly across cosmic distances. When that day comes, imagine a vast communion spanning thousands of star systems, a silent resonance where innumerable beings share thoughts as effortlessly as neurons in a single brain. Yet even without such miracles, the slow communication they have is profound. Knowing that someone out there listens and understands brings comfort and unity. If a star in one corner of the galaxy goes supernova, and a civilization mourns the loss of its light, others far away, upon eventually hearing the news carried by ghostly particles or gravitic whispers, might hold their own vigils under alien skies, empathizing with the sorrow and the wonder of that event. Perhaps by then a song of laughter on one world could spontaneously cause smiles on another, or a moment of sadness in one heart could be soothed by a knowing comfort from across the galaxy. In this way, joy and grief, discovery and contemplation are no longer isolated experiences. They become shared cosmic emotions, binding disparate worlds into one emotional cosmos. Empathy, that delicate bridge between minds, extends now not just across a room or a planet, but from one end of the galaxy to the other, turning the grand loneliness of space into a gentle togetherness. One can imagine, in this age of cosmic unity, an ancient being sitting quietly beneath an open sky, reflecting on all that is connected. Perhaps they close their many eyes, or their single mind's eye, and in the stillness, they can feel the faint whisper of that galactic chorus echoing within. It is a sensation beyond words, a gentle awareness that they are not a solitary mote, but a part of something vast and harmonious. They sense the presence of distant friends in that silence, like feeling the warmth of unseen campfires on a far horizon. In their meditation, the boundaries of self seem to melt into the starlight. In that silence, it is almost as if they can hear a faint music playing, the combined hum of countless souls across the stars. The distant throb of a pulsar, or the gentle rhythm of a galaxy's rotation, might be perceived as the heartbeat of the cosmos, reassuring and steady. When they open their eyes again, they do so with a serene smile, comforted by the understanding that they will never truly be alone in the dark. By now, even the act of being still under the stars is an act of communion with all life everywhere. Time flows differently for these ancient and interconnected civilizations. The hurried heartbeat of mortal years that once governed human life has slowed to a patient, steady pulse. For beings that can live millennia or more, a year might pass like a single breath, easy and light. They have learned to experience time in grand arcs, the blossoming and withering of entire forests, the dance of stars around the galactic center, the slow rippling changes of nebula. All these become meaningful measures. With no urgency pressing upon them, even their creations and pastimes can span millennia or more. They might sculpt entire landscapes or star systems as works of art, content to see the fruits of their creativity unfold over ages. One might plant 1 billion crystal seeds in the ice of a comet, knowing that when it next swings near its sun in 10,000 years, it will sprout a beautiful halo of light for future eyes to see. With lifespans stretching across epochs, they make plans not just for the next generation, but for 100 generations hence. And in their minds, memory becomes an endless river, each moment carefully preserved so that even 10,000 years ago feels like yesterday. Nothing of value is rushed. Wisdom accrues like layers of dew, gently over ages, while they watch galaxies turn with calm eyes. To hold such vast histories, memory itself has had to evolve. Stories of long ago are not allowed to fade into oblivion. Instead, they are woven into the fabric of communal knowledge. Perhaps great memory keepers wander the star lanes, travellers devoted to collecting the lore of every world and carrying it to others, ensuring a continuity of remembrance. You might picture one such traveller, an ancient being gliding in a small lightship between colonies of stars. In its databanks and in its very soul, it carries songs from the dawn of civilization, images of the first sunrise seen by settlers on distant planets, the heartfelt words of countless generations. When it arrives at a new world, it shares these treasures like a benevolent storyteller arriving in a village. People young and old gather under strange constellations to listen, their imaginations lighting up with visions of far-off places, so that all may drink from the well of time. In turn, it gathers the fresh stories of that world's own triumphs and trials, adding them to the tapestry before moving on. Through such exchanges, no single moment of joy or insight is ever truly lost to the void. it lives on, echoed in many minds. With such longevity and connection, the very concept of self and time softens. Some beings choose to experience life like chapters in a book. They live actively for a while, then enter long periods of rest, allowing decades or centuries to slip by as a single peaceful slumber. When they awaken, it is as if a new season of the universe has arrived, with new wonders to behold. Others prefer to live continuously, but slowly, stretching each moment like taffy until even ordinary days feel wide and deep. They measure time not in frantic minutes, but in the grand movements of cosmic cycles, the orbit of a binary star, the slow drift of galaxies apart, the life cycle of a mighty oak tree grown from seeds carried to a distant world. Perspective has expanded so vastly that the past, present, and future all weave into a single vast panorama in their minds. Contemplating eternity becomes a gentle pastime, not a source of fear, but a canvas for gratitude, as there is so much time to learn, to create, to love, and to understand. But even as these civilizations flourish and share across the galaxy, the cosmos around them continues its slow, inevitable evolution. Stars, the brilliant engines of light, live out their lives. The massive blue suns burn hot and die young, ending in spectacular supernovas that for a moment outshine whole galaxies. Smaller stars like the sun live longer, but eventually they too exhaust their fuel and quietly fade into white dwarfs, leaving soft halos of gas, planetary nebulae, like final sighs. The universe enters its long twilight. As eons pile upon eons, new stars are born more slowly, then scarcely at all. The once Milky Way, so teeming with glittering lights, grows calmer and dimmer. Only the steady glow of red dwarf stars remains plentiful. Their gentle light becomes the hearth around which life gathers for warmth. To them, this twilight is simply the gentle evening of creation, a cosmic winter following the long summer of starlight. The descendants of those ancient beings adapt without alarm. They had seen this coming for ages and prepared like one prepares for the quiet of night after a long day. Many gather around the red dwarfs, those faint, long-lasting embers of the cosmos. Planets that circle these crimson suns become sanctuaries, places to linger and watch the fading of the stars in a sky that grows sparer each millennium. Under the dim, ruby glow, communities of minds, some still bearing forms, others existing as fields of data or light, draw closer together. They reminisce about the earlier, brighter times, but do not lament the fading light. Instead, they cherish that those days of brilliance occurred at all, holding them as warm memories to light the long night. They also find new joys in this twilight era. The night skies are darker, revealing galaxies that were once washed out by starlight, and in that darkness, the ancient ones see further and deeper into the mysteries of the universe than ever before. And still, the universe grows older. Trillions of years pass. The red dwarfs themselves, steadfast for so long, begin to wane. One by one, even those small stars flicker out, turning into dark, cold spheres. Where once there were galaxies of light, now there are great cosmic caverns of night. Black holes, the remnants of giant stars long gone, glide through the darkness, slowly evaporating over unfathomable time. Yet even this is not an end for the tenacious flame of life and mind. The scattered intelligences, now incredibly ancient, have become masters of endurance. Some drift near the faint warmth of black holes, using ingenious methods to harvest the meager energy those voids release. A few construct great cosmic engines around those fading black holes, capturing every trickle of energy to sustain the last sparks of civilization a while longer. Others spread themselves so thinly across space that they can catch the sparse photons still traveling from distant past events. To conserve energy, they slow their processes to a glacial pace. Perhaps they enter long sleeps that last millions of years, waking briefly to exchange thoughts with others, before settling again into quietude. In their perception, an instant can feel like a year, and a year like a millennium. A single second of thought might be stretched across an epoch, and in that vast slowing of experience, they find a strange peace. They savour each flicker of warmth, each rare particle of energy, as one would savour a drop of water in a desert. Picture, for a moment, one of the last conscious beings standing on a quiet world under a nearly starless sky. Above them, where once countless constellations glittered, now only a few dim red embers remain, lonely reminders of a bygone era of light. For a moment, they recall how the heavens looked in ages past, brimming with constellations and swirling nebulae, a sky alive with countless lights. That memory is sweet and vivid, warming them like a remembered embrace. The air is still and cool. This ancient observer closes their eyes and reaches out with their mind, sensing the few remaining sparks of life scattered across the darkness. They feel no sadness, only a calm reverence for all that has been. When they open their eyes, they watch as the very last visible star on the horizon gently fades away. In that solemn yet tender moment, they whisper a soft goodbye and thank you into the night, a farewell to the era of starlight. Yet they know this is not truly an end, for the light continues to glow in their memory and in the shared consciousness that still holds every story ever lived. With that thought, they turn inward and join their companions in the final collective dream, carrying the embers of the universe's story into the sanctuary of mind. In the almost complete darkness of the far future, the remaining minds draw ever nearer to one another, a last convergence of thought in an ocean of night. They link their consciousness in ways even we who live in the age of bright stars could scarcely imagine. Individually, they were flickers. Together, they form a steady glow of awareness against the fading backdrop of reality. Instead of perceiving the external universe, which now offers little but silence, they turn inward and create a universe of their own, a shared dreamscape illuminated by memory and imagination. Every experience collected over the trillions of years finds a home in this collective dream. They recreate beloved places, the green fields of ancient Earth under a golden sun, the swirling luminescence of the Orion Nebula as once seen through a ship's window, the towering crystal cities that stood on distant worlds. All are preserved in perfect detail within this vast interior world. Here, they are free not only to remember, but to dream anew. They shape whole new worlds out of stardust in their imagination, create art and stories that have never been, and share them instantly with everyone. In this sanctuary of mind, friends long separated by light years embrace, as if side by side. Even those who vanished ages ago are present in this shared remembrance. So long as a single mind recalls them, they manifest here and walk once more with those who loved them. Extinct species live again in imagination's gentle parks. and even stars that died long ago continue to shine softly in skies of remembered dawns. Within their communal dream, individual boundaries fade. Knowledge, art, and feelings flow freely from one mind to another. It is a chorus of millions of voices, all distinct yet harmonizing in a single grand song. They begin to weave all that they know into a final tapestry of story, the ultimate cosmic folklore. One ancient voice starts to narrate the tale of everything, and all the others join in, each adding their thread. They tell of how the universe was born in a single brilliant flash, an infant cosmos wrapped in fire and possibility. They speak of how, as eons passed, stars and galaxies formed like blossoms in a cosmic spring. They whisper that the stars, as radiant as they were, felt lonely without eyes to admire them and minds to wonder. So out of the dust of planets, life emerged, first simple and then complex, many times, in many places. Life learned to feel, to think, to look up and notice the stars. Through those living beings, the universe began to see itself, to marvel at its own vastness and beauty. That was the universe awakening, scattered in billions of points of consciousness, gradually finding one another and connecting. They share playful myths too, blending ancient cultural legends with cosmic truth. One gentle tale imagines the Milky Way as a great celestial tree. Born from a single seed of light in the void, it spread its branches as galaxies and bore fruit as stars. In this story, each star that ripened on the tree gave life to a world, and each world in turn birthed stories and dreams, all of which the great tree cherished in its cosmic heart. Another fable speaks of a primordial ocean of night, and how the first songs of living beings created waves that shaped the stars and planets. These star-born myths, though poetic and symbolic, carry a deep understanding. They express that life and the cosmos are entwined, each giving meaning to the other. Even the most advanced among them finds comfort and wisdom in these simple tales. They tell them to their children when gentle night falls on their worlds, lullabies about the stars, to remind each new generation that they are at home in the universe. Their story continues through the ages of light, into the ages of dark, and finally, to this very moment of union. They conclude that when the last spark of matter finally fades, it is not a tragic end, but a gentle farewell. The universe, having experienced itself in every possible way, closes its eyes. In their collective myth, the cosmos falls into a deep, serene sleep, dreaming sweetly of all the life and love it fostered. There is no fear in this ending, only a profound peace. All that ever was, every laugh, every quest, every song, now lives on as a single everlasting memory, cherished in the universe's final heart. A few among them muse that perhaps this cosmic slumber is not an end at all, but the prelude to a new dawn, a new universe that might one day be born from the old, the way morning follows night. But whether or not that is true, it changes nothing in their hearts. They are content to rest, wrapped in the mystery, at peace with all that has been. Over these hours of gentle exploration, we have watched the cosmos unfold its story. From the first wanderers among the stars to the merging of countless minds into one. We witnessed humanity reach beyond its cradle, saw new forms of life dance in the starlight, and felt the universe itself awaken with awareness. Now that story has come to its quiet conclusion, and with it comes a deep and tender peace. And so, at the end of this long journey through time and space, we arrive at a place of rest. And as we reflect, we remember that we ourselves are woven from this cosmos. The atoms in our bodies were born in stars that shone long ago. We are truly children of the universe, intimately connected to the vastness around us. Now, let your eyelids grow heavy, like the dusk at the end of a long day. In the grand dream of the universe, your own dreams are tiny constellations, twinkling with hope and serenity. Allow yourself to drift away, carried by the same currents that guide the stars in their courses. You are safe. You are loved by the night, and the cosmos wraps you in its embrace. It is as if the stars above are singing a gentle lullaby, just for you, a distant chorus of light and calm. In this unity of all things, you can finally rest. There is nothing left to do, and nowhere else you need to be. Your journey is complete. Simply float in this silence, at peace. Notice the weight of your body sinking into your bed and the ease that fills each muscle. Any remaining tension melts away with each soft breath. Your eyelids are heavy, your whole being loose and relaxed. Sleep now, as gently as the universe sleeps, and let the quiet darkness carry you to a place of deep and healing peace. Deeper and deeper you drift, carried on a gentle tide of dreams. In this way, you become part of the cosmos's own dream, resting in unison with all of creation until the gentle dawn. Good night beneath the endless sky, and sweet dreams, dear friend.